All right. I'm here with Kevin Folta. Kevin, you're a scientist, a GMO foods expert, and if there is one subject that gets beaten to death online and in conversation and butchered, I've heard many conversations that I had to just walk away from at parties where people started talking about what GMO foods do and what's going to happen and all the horrible things. GMO foods are probably one of the most confusing and also one of the most hated things in the world today, but also one of the most common and most misunderstood, right? I mean, almost everything. There's a Neil deGrasse Tyson did a video about this where he was kind of explaining like the term GMO foods, like virtually everything you see, including things that are quote unquote organic at a supermarket, have been modified in some way in order to prolong their shelf life, in order for them to taste better, including corn and tomatoes and oranges and you name it.
Yeah, I think that's the big problem, is that, and you framed this very well. The problem is that we confuse this idea of GMO, which is kind of a pejorative term that we've derived to kind of misrepresent this kind of technology, which is really just plant genetic improvement. Like you say, we've been improving plants for 10,000 years as a species. We find the ones that work best, and we continue to select those particular lines that have benefits for us. And we've been doing this for a long time. So everything is different than it was in the wild. If you look at the natural forms, they're nothing like what you see today in the store. So this GMO thing is just the most recent way that we've been able to modify the way a plant behaves and what plant products are. And it just is a much more precise extension of conventional breeding.
But there is a company that looms like the Death Star out there in the world of GMO foods. And that company, I don't even have to say the name, it's spoken in hushed terms around hippie campfires. Monsanto,
yeah.
Right? Mm-hmm. And, well, Monsanto is also responsible for a lot of good things, I'm sure. They have done some creepy shit, and they have gotten, especially in India, I mean, they're directly connected to the suicides of countless farmers who can't afford to use their seeds that they have to replace every year. I mean, there's good and bad when it comes to the ability to modify things. And I think what terrifies some people is that a company like Monsanto, which has just ungodly amounts of money and influence and power, I mean, they've been sued by the Brazilian government, and Brazil sued them and won. And I don't know the exact specifics of the case, but it's essentially about those seeds that explain those Terminator seeds, if you could, and how those things were created.
Okay, so you touched on 3 important points there, and we can come back to the suicides and also Monsanto being a giant company. And I should note right off the top, I have nothing to do with Monsanto. I'm not, I don't work for them. I'm a scientist at the...
But wait a minute, I've read online that you are a shill.
That's right.
You are not a shill?
I am not a shill. I'm a shill for you. Actually, I'm a public scientist.
Yes.
I work for the University of Florida. I'm the chairman of a horticultural sciences department in a state where we grow almost no GM crops. The difference is that I see tremendous potential for how these technologies could be helpful for our farmers. And we try to get them excited about ways that we can apply them in the future. But let me go back to your last question about, because I don't even know much about this Brazil issue either. But
Jamie, I'm sure you could pull up the article so
yeah.
if we could see it on the big screen.
Yeah, so the last question out of that was the
Terminator seeds.
The Terminator seeds. And the Terminator seeds, this is something that never existed in terms of a product that was available. A company called Delta Pine and Land back in the 1990s developed a technology to ensure that genetically engineered seeds would stay in the fields they were planted, that you wouldn't have pollen leaving and pollinating something else and creating plants in other places. Pretty good idea for containment. And Delta Pine and Land had this technology where basically the embryo of the seed didn't develop properly. So it was a dead end. You couldn't replant it and get it to grow. So when Delta Pine and Land later was bought out by the Big M, by Monsanto, everybody saw the Terminator. Well, it wasn't called the Terminator seed. It had some other name, but it quickly gained the name Terminator. And so these were never grown outside of a greenhouse, and the company has said they never will grow them outside of a greenhouse just because of the overlaid implications of what they might mean.
But there have been instances of GMO crops by pollination infecting the lands of people who are not supposed to have these Monsanto crops on, and they were sued for having these crops growing on their land, correct?
There's examples where people have had litigation because they've generated the seeds that are a licensed product. So in other words, when you're a farmer, you buy the seeds from the company, and it's Monsanto or any of the companies that sell the seeds. There's 6 different companies now. You buy the seeds from any of those companies, you fill out a form saying, I agree to not grow more of this. And so there are cases where people have grown more of it. And it hasn't been from a little bit of pollen drifting into a field. The court cases are all public record. In the ones where they've been successfully tried and litigated, they've been for thousands of acres of plants that someone would knowingly grow and maybe even treat with Roundup in many cases so that they were selecting for the trait. The intent was to sell the seeds that they agreed not to sell.
Oh, okay. So these stories about farmers that were getting sued because of cross-pollination, because the GMO crops have infected their land, is not true.
That's not. There's no evidence in the record to show that this is substantiated. And what's even more scary about that is that when the company has litigated any of these and won favorable court decisions, they haven't kept the money. That any damages went back into the community. So. Again, that seems.
What do you mean by that? Like damage just went back in the community?
Meaning that if they sued a farmer and actually won the case, any of the funding that was won as a penalty from that case was given back to the community where that farmer lived.
Back in what form?
I guess just financial support for whatever. It was just the idea they wanted to get around was that they were somehow suing farmers to get rich or to pocket the funds. And so they created this this plan or this program to put the money back where it came from.
So where do these farmers get the seeds then? If they illegally acquired these seeds somehow, is that what's the implication?
Well, if you were to go buy corn from, let's say, Monsanto or Dow or any of the companies that make it, and you were to grow, say, soybeans that were Roundup resistant, so that they resist the herbicide. You can kill the weeds but let the plants grow through. If you were to buy those and you were to spray them, and then keep the seeds and then bulk them up and then start selling them out of your garage, the company would come and say, no, you can't do that.
So this is what you're doing is you're taking the corn, and the corn itself is essentially a seed, right? Like
right.
the actual the ears of corn, you can grow corn from that corn. And that's what they're doing.
Yeah, so they're essentially, and maybe not corn as much, and I can get to that in a second, but things like cotton and soy, you can't, it's a lot like software. And Dr. Anastasia Bodnar is an excellent example of this. You can't go buy a copy of Microsoft Office and go home and make 1,000 copies and sell them on eBay without Microsoft knocking on your door.
Right.
This is technology that takes years and years to develop. It's a really expensive technology to deregulate, something like $130 million sometimes to deregulate one of these genetically modified lines. So the company needs to make money to maintain its R&D. And so they ask farmers, who are the beneficiaries ultimately of this, to sign an agreement saying that they'll buy it every year.
So this is the lawsuit, the Brazilian lawsuit. If you scroll up, Jimmy, so you read this whole thing. It's they face a $1 billion. Well, this is in 2013. They lost the lawsuit. This is not a recent article, but the farmers that were suing for abusive purchase contracts. So scroll down a little bit there. Brazil farmers court actions are piling up against Monsanto for collecting royalties on RR1. Is that Roundup?
Yeah, Roundup Ready 1.
Regarded as illegal and for conditioning the sale of new GM seeds I don't know what that word is, Intaca RR2 to the signing of a contract seen as abusive, according to an article for Valor Online Brazil. Lawyers for the farmers and representative bodies estimate that the value of the claims against Monsanto at 1.9 billion Brazilian reals, which is about US 1 billion. Processes have not been completed, but preliminary estimates say that the claims may affect the company's profits. See if you can find a more recent article, because they lost that lawsuit.
And I have no clue. This is also coming from Sustainable Pulse and GM Watch, two sources which have nothing positive to say about biotechnology. And it wouldn't surprise me if other countries did try to litigate these kinds of examples. I mean, it's anybody can sue a company. You know, anybody can do it. So it's possible that these things were brought before these governments, saying that these were unfair practices to farmers to make them sign a contract and then repurchase the seed later on.
So these seeds that you were talking about before, how did these folks get them then? Have if they're getting enough seeds to plant thousands and thousands of acres illegally? How are they doing that?
Well, you just save the seeds from the previous year instead of processing it. You know, you can imagine a corn cob has several hundred kernels, and each one of those represents a new plant. So you can have X amount of your acreage dedicated to seed production.
So essentially, all you would have to do is buy, you know, a few thousand ears of corn, and you would be able to plant just a giant area of land.
You know, and I wish I knew the number off the top of my head, but I don't. But it would be able to replant more seeds. Now, corn's a bad example because corn are hybrids. And without going into a whole genetics whiteboard thing here, every corn is made from two parents that are genetically very different. But when you combine them together, give you a hybrid that when you cross a hybrid with a hybrid, gives you a mixture of seeds that don't give you any uniformity in the next generation. So since the 1930s, the seed companies have been able to resell that hybrid seed to farmers every year because there's nothing to be gained in producing your own. And so corn isn't always the best example, and the companies have used genetics for going on a century now to protect their breeders' interests.
So the original corn, is that someone's phone? What was that? The original corn, before it was modified at all, was that corn that you get like for Thanksgiving that you hang on your door that nobody eats, that weird colored funky looking corn? And it was even smaller than that, right?
Oh yeah, the original corn was called teosinte. And teosinte was basically growing on a bush in Mexico, and it gave you 13 little hard kernels on a stick and a plant would produce some of this. And it's now being thought from archaeological evidence that peoples would take these little corn cobs, which to call it that is kind of strange, this little stick with little rocks on it, and stick it in fire and pop it and eat it like popcorn. Because it's too hard you have to use a lot of water and grinding to make any food out of it. But you can imagine how exciting it was when you were a person who was using this for sustenance, when you found a teosinte plant that maybe made twice as many, or maybe instead of 13 kernels gave you 26. And so you would select those and plant them the next year. And it's really interesting that now you can go back through the 10,000 years of corn improvement, and we've been able to identify the genes that were at all of the critical thresholds that shifted this thing from being a bush with lots of little sticks of kernels to being what it is today. And it really is just a small number of genes that were changed.
So before they started modifying genes, how did they select? Like, say, how do they, because before any genetic modifications were done in laboratories, they had turned this what did I say it?
A teosinte.
Teosinte, or maize, as we used to call it. Right, that was the Indian word for it.
Even according to that commercial, I think that's
BS.
Yeah. Well, maize is kind of a general term for everything from field corn, which is what we think about, which is fed to animals.
Right.
Which 80% of GM crops go to animal feed.
Right.
And so we differentiate that versus what is typically eaten by humans, which is usually sweet corn varieties.
So, how did they turn it before there was any genetic modifications done in laboratories? How did they turn that corn into what we eat now, which is delicious and sweet, and you put butter on it, it's fantastic?
Oh, sure.
How did they do that?
Yeah, actually, but it was all just random mutations. DNA
Random?
Yeah, DNA replication is a sloppy process, and funny things happen when you, environment. So in the process of replication of DNA itself, you can make errors. Cosmic radiation, just chemicals in our environment, natural chemicals that are out there can induce changes in DNA. And these kind of mutations sometimes, very rarely, result in a change in the plant that's beneficial, and at least from a human perspective. So in all the plants that we've had, all the plants that we have, the significant amount of change has come from random mutations that change genes in ways we don't understand, pieces of DNA that get up out of the genome and sit down somewhere else randomly. They do this all the time. Viruses in the plants that get into the genome and sit down in places that we have no idea where. So genetic modification is something that's ongoing and constant and a factor in every genome, including our own. And so what we're seeing today is just the long-term effect of humans who've been able to put all the good traits in one place.
So when you see those tomatoes that are in the supermarket that are pale and you could play basketball with them, those hard tomatoes, and then you compare them to like heirloom tomatoes, the only difference between those two is that someone had found some tomatoes that had grown extra firm and selected those and used the seeds from those to create more similar tomatoes and only selected those.
Right. So you framed two cool things here. So heirloom, what is an heirloom? And an heirloom is a tomato with outstanding eating qualities that can't work in production commercially.
Because it's too mushy.
It's too mushy. They don't last long. Right. They break down. But on the other hand, so this is what the problem is with our food. When you talk about tomatoes, strawberries, blueberries, these are non-GMO, by the way. There's no GMO tomatoes or strawberries. Not at all. People would say there are. The problem is that plant breeding over the last 50 years, or say over the last 100 years, the objectives of the breeders has been bigger fruit, uniformity, big yield, disease resistance, nothing about flavor and aroma. So to meet production characteristics, which is what we've been selecting for, breeders have been looking for these kind of characteristics that don't involve the consumer. And so our decline in the flavors and the quality of fruits and vegetables is directly related to the mass breeding, not anything to do with GMO.
So when you say genetic modified in those terms, they are kind of genetically modified, but they're not modified in terms of being in a laboratory and human beings doing some funky stuff with genes. They're sort of modified almost naturally and just selected for those modifications.
Exactly. And some of the things that we've selected for have been the ones that didn't kill us when we ate them, or the things that didn't make a poison that or something that tasted horrible. Plants make lots of funky compounds. And so this was an opportunity for, so what we've seen in our stores right now is the residue of thousands of years of human selection. And we can call it genetic modification if we want to, but we can differentiate it from what we do in the laboratory, which is now we can call adding a transgene or a transgenesis, moving a gene from one background of genetics to another via a laboratory.
And these selections that people have moaned about, and I have as well, I mean, it's horrible when you get a sandwich and it has a pale tomato in it because they just taste awful. So there's no science involved in any of that other than selection. There's no like injection of some alien sort of genetics into those things, alien to the plant.
No, there's no syringes, nothing like that. And actually, you know, it is more an art than a science. Being a plant breeder is the most kick-ass career these days and has been for a long time. Plant breeding is essentially inventing the next generation of food. And all we're talking about is mixing pollen from things that maybe normally wouldn't cross together, like something that in nature would never cross. But you got this cool tomato from Europe that has great qualities, and we can mix it with this great production quality tomato that grows in Florida where nothing else can grow. And now you mix these two together and you get this beautiful tomato that works well in everybody's garden. That's where we're going now. But that's not GMO. That's just using other types of technology to facilitate this breeding process that breeders do.
And how would you splice those two together? Like, how would you take a tomato from Europe and a tomato from Arkansas and somehow or another make them work?
Well, most of the time it's as simple as plant sex. You just you emasculate one of them, you rip all the male parts out of it, and then you add pollen from a different flower. And it's very simple. And that's what people have been doing to create hybrid varieties for centuries.
So that is not considered genetically modified, or it is?
Well, and this back to the confusion. It is certainly a genetic modification. You're ramming together genomes that never would have mashed together
in the wild.
In the wild, never. But in creating a product that humans have never seen or tasted or tested. But yet we find this very acceptable. And very, even though it's a very random process, we don't know what kind of those transposable genes, those things jumping around genomes. Two of the main corn types have 500 different genes between them, meaning one has 500 genes the other doesn't have. So you're mixing together things that have no commonality other than the basic core guts of genes in the genome.
So this is not, I don't think, like those splicing of things is not what terrifies people. What seems to terrify people is the introduction of things that are not supposed to be in the organic plant. And this is something that really bugs people. And the real fear is of disease, is of cancers. And there's all these studies that have been done supposedly of rats that got cancer from some sort of Roundup crap. Like, explain that.
Okay, so let's dive into that. So when we're adding genes across, let's say, species or across kingdoms through a laboratory, and that's what people, I think, are really get strange about, or really don't understand. This is the part where it's actually terribly simple, and we've been doing this since the 1980s, introducing them to the plants since the 1980s. I've been studying it since then. And the best example is insulin. That the human gene for insulin is cut out of the human genome, placed into a bacterium, and then gigantic fermenters of bacteria. So we're talking like an organism that is so different from humans. And then we pull out the insulin, and we use this to inject in the patients rather than relying on isolating it from calf or cow pancreas, where there can be all kinds of allergic reactions and all kinds of other issues. So here we have a source of insulin that's human insulin that's coming through a GMO intermediate that allows humans to live for a low-cost medicine that has no side effects.
And there's a bunch of instances of that, aren't there? It's not just insulin that they've done with breeding it with bacteria. It's a bunch of other things too, right?
Right. The main enzyme for cheese making is called chymosin, and is a camel gene that's expressed in a bacterium. And,
camel gene?
Yeah, it seems to be the most efficient at doing the job that chymosin does.
Okay, how the hell did anybody ever figure that out?
Yeah, you just test everything. You know, you try everybody's different. It's one of these enzymes in the gut of one of the chambers of the gut of the ruminant's stomach, and the camel seemed to have the one that was the most active in vitro, because you can do this test. You put the different enzyme in a test tube and see which one converts the milk into the cheese stuff faster. And then you're able to figure out camel one, just because it's a better enzyme for whatever reason. Now you use that one in bacteria. And 95% of cheese, it uses a GMO intermediate.
That is insane. How the hell did anybody ever come to the conclusion that a camel would produce the best cheese?
Yeah, but that's what we do. That's what I do. And that's what my colleagues do. You know, we've got this really cool system of public universities where we're using money from public funding, from, you know, your tax dollars, to solve problems like how to make better cheese less expensively. That's our main thing as a land-grant university. And so these are the basic science questions that we strive to answer, and I think we are doing a good job with. And that's why this GMO thing is so frustrating, because we're so down in the Monsanto noise, and we're so in the noise that we have solutions that we can't use. So like the camel gene, you know, things that we don't think of that we figured out.
Is it because of the name, like because that name is associated with this big evil corporation, that all GMO foods are sort of looked at in this regard? Because, I mean, people aren't freaking out about camel genes and cheese because they didn't know about it. But everybody knows about GMOs, and they instantly connect that to Monsanto, and they instantly connect Monsanto to greed and callousness and Indian farmers committing suicide, as we talked about.
Oh, yeah, we got to come back to that, too. Don't let me walk out of here without hitting that. But this is the problem, though, is that when you look at the real solutions that are there in science, the stuff I care about, you know, Monsanto, if they went away tomorrow, it wouldn't affect the fact that the science is really good.
So they're a company that's profiting off of the science, essentially.
Well, they sell a product to farmers. Farmers want improved crops that take, and the big deal for farmers, we have 1% of our people in this country are farming to feed and clothe the rest of us. It's such a small amount. They're getting by on narrow margins. And when you're talking about the disasters that come from heat waves and floods and everything else, they're operating just by breaking even. And so farmers who can get improved seeds that maybe don't require an insecticide because the plant makes its own protection, that saves a farmer big bucks in terms of fuel, labor, products that they don't have to spray. And so farmers have adopted the GM technologies faster than cell phones. I mean, these went from 0 to 95% of acreage in just a couple of years for 5 crops. So farmers buy the crops, Monsanto makes the seeds, Monsanto makes the seeds, the farmers want the seeds and demand more, and that's why Monsanto stays in business. They make a product that farmers use.
The Indians.
Yeah.
Indian farmers committing suicide. What's the story behind that?
So the best place to get information on this comes from academic sources. And if you look at Ronald Herring, who is a professor at Cornell University, he's looked at this question very much. Suicide is a major issue in India, and it's very common and now more than ever among young women, and certainly is an issue among farmers. They plant a very risky crop. That's cotton. Cotton is a difficult to grow crop that in most areas requires lots of water. And if you don't get monsoonal rains, your crop fails. So where this idea that Monsanto crops were somehow causing farmer suicides comes from the idea that the seeds are more expensive, farmers go into debt to some degree to buy them, and then when the crop fails, they lose the money. It doesn't have anything to do with Monsanto per se or with those particular crops. The other big issue you have is because these crops, so these are cotton plants that make their own insecticide. They make a protein completely benign to humans that protects the plant against the weevils and other critters that burrow into cotton. And so farmers don't have to spray pesticides. And it's a huge deal because it allows them to farm without having the cost of it. They all want this. Well, many of them want this. They buy these seeds. Now the problem is there's a counterfeit seed market where people are selling something that isn't legit. And there are legitimate problems with farmers who commit suicide because of indebtedness. But I don't know how much we can directly blame that on the company or its agents.
So if someone buys Monsanto cotton, say, they buy cotton seeds and you grow cotton, that farmer has to make an agreement to not use that cotton to plant more cotton, that they have to buy more seeds.
That's right.
That's the case? See, that's where it gets really confusing with people because they're like, well, why? It's a natural process. It's a natural process. If you buy that corn, and you take that corn and continue to grow corn, that's always been how farmers have done it throughout the beginning of time. Now, all of a sudden, some company comes along and says, no, we own that corn. We license you that corn. You grow the corn once, and then you have to continue to buy seeds from us to grow corn. That was never the case before in human history. This one company comes along and demands that, and that was connected to the suicides of these people in India, that this is a totally new situation.
Actually, very, very much not a new situation. Plant variety protection and protection of plant genetics has been around since the 1930s. And farmers, as I mentioned before, have been doing this strictly by using hybrids, which don't yield decent plants in the next generation. So you had to buy them from the company every year. More recently, and if you wanted to, let's say you bought an apple tree for your apple orchard from Cornell University, one that Cornell University devised. So we don't even talk about Monsanto. Let's say a public university. The apple trees are all propagated by vegetative cuttings. You cut off the little branch, you grow roots on it, grow a new tree. And you sign a licensing agreement, non-GMO. But there's things like that, strawberries from University of California.
You sign a licensing agreement, and what does that entail?
It says that you will not propagate those plant materials as a farmer, that you'll use them to grow your crop, and that when you need more, you'll buy more. And the reason it's...
And when was this done?
Well, these have been done for decades. And it's more and more
popular. So the 70s, the 80s, like when was this? When did this started?
Started back as long as the 1930s, but wasn't really done very often. You really started to see an escalation of plant variety protection, non-GMO plant variety protection, in the last couple decades.
So in the 1930s, did they, let's say with apples or something like that, someone figured out a way to selectively breed a really excellent apple. They protected those seeds to the point if you bought seeds for those apples and planted them, you were not allowed to extract the seeds from the apples that you planted and grow new seeds or grow new plants?
Well, it's sort of. You couldn't. Apples are propagated by the cuttings rather than seeds because every seed is a genetic mess. You can plant an apple. You buy an apple, Red Delicious apple. You could plant the 20 seeds inside, and you're going to get 20 plants that are nothing alike, and none of them will have decent fruit.
None of them.
The ones that have the blockbuster traits, and this is why there has to be protection. For us at University of Florida, to grow a new orange variety might take 30 years. It might take acres and acres that cost the university hundreds of thousands of dollars a year to borrow or to lease. The pest treatments, the fertilizer, the water, the labor, it costs hundreds of thousands, maybe $1 million to bring that new variety to market. And to have to just give it away it ends a breeding program. So
wouldn't the solution be to publicly fund the research so that the people benefit from it? So instead of a large corporation being able to lock down this perfect orange that you've developed at the University of Florida, instead the taxpayers' dollars, which goes towards the research, creates this beautiful plant that everyone is allowed to benefit from.
Well, that's what happens, is that the public good or public research, publicly funded, says you get a little dribble of dollars. But our breeding programs are very much self-sustaining in many cases, that you need to commercialize your best selections or your best fruit in order to be able to keep the breeding program going.
So the university has to generate money through its breeding program, and then it has to protect that money to ensure that they will continue to receive money from all the different things they develop in their lab, which will justify the amount of money that you spend on your research.
And it's not much. I mean, we get a tiny bit that comes back in terms of individual, the percentage. It's not much at all. But most of it goes to the breeding programs that allow them to continue to be leading breeding programs and hire people and lease land and produce the next varieties for the public.
And the only way to do that is to make sure that people don't take your orange and take the seeds and plant new oranges?
And because if people do illegally propagate this and compete against the nurseries that are doing it legally and selling it to farmers, you have a couple problems. One is you lose control of the product quality. Is it really true to type, what people say it is? Really the beneficiary is the farmer. We make something that the farmer wants and that the farmer is desperate for. Our farmers we have an orange problem right now in Florida that's coming here. We have 60 million citrus trees that are dying, and we're doing everything we can to identify resistant material, not GMO. Well,
what
GMOs,
are they dying from?
Something called citrus greening disease, Huang Long Bing. It's a disease that's...
I know that dude.
Yeah.
Sorry.
Yeah, I've seen all his Bruce Lee movies. Yeah. He was citrus greening disease is a disease where bacterium blocks the vasculature of the orange tree, and it's spread from tree to tree with something called a psyllid. It's an insect, and there's jillions of them. And this thing bites one infected tree, goes to another, and now spreads that bacterium that can live in that tree for 5 years before there's any symptoms. And then the tree just gets sick and starts to die. We've got an orange industry that is half as big as it used to be, and we need a solution. And that's why our breeders are making everything they can to generate new trees, accelerating the process, everything they can. And if they can get that new tree after they spent millions of dollars, some of it from the USDA, to identify a solution, there has to be a way for some of that funding to come back to the program to invent the next generation so that now we're ready when the next threat comes.
So what would be the solution? Like, say if you have some sort of bacteria that's infecting these plants and killing these oranges, what could be a potential solution to that? And what would be the ramifications if you didn't come up with a solution?
Yeah, so the cool part about this is that being where I am at the university, and I'm the chairman of a department that does everything from organic and sustainable biology all the way through space biology, you see people attacking this from so many ways. We're changing the plant's nutrition. We're changing just the root stock. So citrus trees are a bunch of roots in a scion. So you glue two together, you graft them together. Talk about a frankenfood. We're building root stocks that can generate resistance to the bacterium so that now when you graft on a scion, maybe it will be resistant. We're doing everything from insect control. We're doing everything from essential oil treatments, novel drugs that are used in humans and approved for humans being applied to see if they can kill the psyllid. Or
like an antibiotic or something like that?
Well, it's hard to do antibiotics because of the resistance factor, that people are resistant to using antibiotics on trees because they're afraid they'll get... So this is the defensive, weird science environment that we have to work in as public scientists. Mm-hmm. We're trying to identify compounds that are approved for use in humans or approved for use on food that might have a shot at it. And we're trying everything. Some of the things that have worked very well are GMO solutions. And so there's a company in Florida that is looking to commercialize a spinach gene in orange that solves the problem. We have a couple of them at the University of Florida at our Lake Alfred facility where they're genes that directly affect the bacterial growth. And they work well, and they're not harmful to humans. And the trees are now 5 years old with no symptoms. So here's an example of a GMO solution. It's not Monsanto. We can't solve this problem with breeding, not easily anyway. And here's something that we can solve this in 5 years. Thousands of families, thousands of Florida families, thousands of California families are watching their groves, waiting for the yellow symptoms to appear, and we have solutions. But people will fight us tooth and nail from applying them. And that's where I, as a public scientist, that's why I want to be here to talk to you, because I'm looking to appeal to people's intellect to divorce the technology from Monsanto. Divorce this technology that you have in the public sector that can be used to solve public problems that are important.
So there's a tremendous amount of fear that's attached to these subjects, and with that fear, there's often very little investigation, which is unfortunate. But it's also very rare to get a person like you to sit down and talk to them and explain this, and it takes a long time. And so I really appreciate you being here for this. But there's a lot of fears that people have that are founded in fact and founded in actual consequences, like MRSA. You know, what did MRSA come from? It's a medication-resistant strain of this horrible staph infection that people get. But it's staph. I've had staph. It's horrible. It's nasty. And the antibiotics you take are ruthless, and they leave you like a zombie. I had a headache. I felt terrible. I mean, it was really weak. I could barely open up a jar of pickles. You know the feeling. Mm-hmm. The medication has created a resistance to this medication. Bacteria that have survived the medication and have grown stronger because of that, and that is a fear that people are worried about, that there's a balance to nature, and that when you screw around with that balance, there's unintended consequences, and oftentimes they can be deadly, like MRSA. And this is something that I think people are... I mean, it gives them cause to worry about someone putting antibiotics in their food, whether it's in their chickens or whether it's in their, which they've started to do less and less of. And I think it was Tyson Foods that publicly stated that they were going to significantly decrease their use of antibiotics and try to cut it out entirely because of public concern. I think it was Tyson Foods. See if that's true. But this is a real concern, right? I mean, doesn't that make sense that people are worried about that?
Well, absolutely. I think, and I'm not so worried about the meat industry and antibiotics. Mm-hmm. Like, that doesn't faze me too much. But the idea of MRSA, okay, and all of our resistant bacterial strains, that comes because of an overuse of a silver bullet technology. These things come about because the mom has a screaming kid who says he must have an ear infection, so I'm going to demand from my doctor that I can get antibiotics. It comes from those of us saying not taking them correctly, taking them for a few days and then not taking the whole bottle as we're supposed to.
But I see, I've been told recently that that's not the case, that was what they had discussed. They had believed that for a certain amount of time, but now they no longer believe that it's necessary to take a full, that it doesn't do anything bad to create or to take a shorter dose of it.
Okay, I don't know the literature on that, so I'll have to get back to you.
If I can find. There's so much science.
I try to shoot from the stuff I'm really solid on, but the long story short is that, and it came up a lot online. If we can segue into that, they talk on the Twitter feed before we talked. A lot of concerns about the super weeds issue, and it's the same idea that because the Roundup resistant technology has been so successful for farmers that it's what they overuse or they constantly use. Now you see resistant weeds that invade those fields that are resistant to the compound, just like in MRSA. And it's from using a silver bullet technology. The reason that that's a problem is because the process to come up with the next generation of solution is so arduous and so expensive that we stick with the old technology and we can't come up with something new fast enough.
So this silver bullet technology, this antibiotic that we've created to deal with very specific infections, it works, it's very effective, so people use too much of it, and because of that, then it creates this medication-resistant strain of this, and there's not enough research done to fight off that medication-resistant strain of it because it's so cost-prohibitive to do the work to create a medical solution in the first place.
I think you're right. I think because the main issue, remember, go back to this idea that DNA has natural mutation and natural problems in its replication that give new information in a cell. And when you get that MRSA infection, those cells are dividing every 20 minutes, and you have millions of them. And so the chance of one gaining the ability to metabolize your antibiotics is actually pretty good. And when you're talking about billions of cells over many generations, that's where these things come from. It's kind of funny because actually I have an appointment on Wednesday morning because something out of my lab, I have something that looks like it would be a potential ability to make the next generation of MRSA. We're actually going to test it on MRSA. And something that I came up with in plants that we're patenting that makes new compounds that could be very helpful against other creatures outside of plants.
Okay, one of the things that troubles people the most about genetically modified things, whether it's foods or whether it's animals or anything that we're messing around with, is the potential health risks for the people that consume them. That is the biggest problem, probably the biggest concern. People are worried about cancer. And I've seen people tweet this at you. You're a scientist, but you're not an oncologist. You're not a cancer expert. You're not dealing with people that get sick from certain things. What evidence, if any, is there that medication, or rather that genetically modified foods cause diseases in people, cause sickness in people?
Yeah, so this is the big issue. Let's look at that backwards. We've been growing these things and eating them now for 18 years and studying them a lot longer, 30, in terms of feeding them to animals and everything else. There has not been one case of one single health effect that's been attributed to this. So it looks like it's, I mean, in my perspective, these are some of the safest products in the history of humans. And so we haven't seen anything come out. On the other side of this, these are some of the most extensively tested crops in the world. They start on the drawing board. When you say you're going to take a gene from Bacillus thuringiensis, this BT gene, the thing that we use it's actually called CRY1A or whatever it's called. CRY is the acronym. We won't get into the details. You take this gene from the bacterium, a bacterium that's used to protect organic produce, it works fine there, and you take that gene which encodes the protein, so it's the information from the cell that allows the cell to create this protein that targets the gut of a lepidopteran insect, so the caterpillar of certain birds, butterflies and moths, and now the plant makes this protein. You can do the tests in vitro. You can say, does this protein affect cells? Does this protein affect animals when you feed it? Does it affect animals that you feed it at tremendously high levels? All those tests are done ad nauseum. And this is a natural protein that's digested just like any other protein.
So is there any risk at all of messing with food and introducing antibiotics in food, whether it's in the tree of an orange, and is there any risk for humans that consume that?
Absolutely.
Absolutely.
See, I have to answer it like a scientist.
Okay.
All right.
I appreciate that.
You can never say there's no risk. And what we have to say is that there's risk in anything we do with genetics. But we live in a time where we have this unbelievable sensitivity to detect something in a plant. We can look at the metabolites we can take a plant as it is, add a gene, and see what changes with unbelievable resolution. We can look at every single protein. We can look at every single gene that's turned on or turned off. We can look at where the gene that's added is integrated. We can understand metabolite profiles or screen for specific carcinogens. It is so easy right now to be able to do a very careful assessment. You know, I'm not in this ball game to hurt people, and farmers aren't either. I mean, they want to produce wholesome food for people. My job as a public scientist is to use, my ability to dream and think of ideas and solutions for public benefit. You've got tens of thousands of me out there. The person who found something wrong would win a Nobel Prize for it. it's that much of a big deal if there was something wrong.
But to play devil's advocate,
sure,
if there was some sort of a reaction in 1% of the people, or less than, let's say 1/10 of 1% of the people, that was deadly, but the company, whether it's the Big M or some other company, is making $1 billion a year off of this, there would be a tremendous amount of pressure to continue that money flow in. Whether it's through, I'm not saying it's through scientists. I certainly wouldn't think it would be through people like you. But I would think that somewhere locked away in some office high in a gun turret is some evil asshole who owns a giant stake of the corporation, and he's like, let them die if they eat our coal. Who cares? Look at all the money. There's that. That's the thought. That's the big worry, is that they would hide it. Like, the story of GM and the ignition switches?
No, it's a great example.
They hid the fact that their ignition switches were faulty and people died, and now they're being sued, and it's horrible. And that's GM. I mean, they made the Corvette. They made the Bel Air. I mean, this is how is this possible that people that make Cadillac would be evil?
The first 2 letters of GMO.
I know, right?
There's the conspiracy. No,
but it's also GMT, which is just a time.
Yeah, no,
it's innocuous.
Yeah. But the big deal is I agree with you. When you start talking about money, you can look at many examples throughout history. Whether you're talking cigarettes, you're talking, where you see examples where money has bought influence. And
sure.
But the beautiful part of this is that science always wins. And that you do find out, the truth comes out eventually. And for these companies that are producing these products, in my opinion, and I'm not with these companies, I can't tell you how they think, they stand to make a lot more money by making a product that's thoroughly tested and being clean with anything they would find that would be problematic. The other thing that's really important here is that we know, so when you say you're going to move, let's say now we're going to talk about rice that you can add genes to make it have high beta-carotene content, higher vitamin A content.
Like a golden rice.
Golden rice. You know what those genes do because we studied them in carrots. We understand the products they produce. So there's a plausibility aspect to this too, that when we take this from carrot and put it in rice, what's the difference? Now, maybe there are some differences, and we can test for those. But it starts out with the plausibility. This isn't magic and voodoo and weird backroom, let's see what this lever does.
So the idea is that if you eat carrots and rice together as food, that's not much different than splicing carrots and rice together. And likely, if you're not allergic to either one of those things, you're not going to be allergic to this rice that you create.
Absolutely. And even if you are allergic to carrots, taking one gene out of it that doesn't have a immunological footprint, an antigenic footprint in humans, like the genes associated with beta-carotene production don't have, you'd be able to move those into rice and have no problem.
That's a good point, the point of allergic. Because biodiversity is a huge issue when you're talking about foods in general, that some people have extremely different reactions, whether it's to peanuts or to shellfish or to a variety of things that most of us enjoy, but there's a few people that have severe reactions to this very same thing. And this is natural, completely, totally natural. This is the question when it comes to certain types of medication. If you're dealing with these outliers, if you're dealing with this 1/10 of 1% of the population where this chemical reaction happens inside their body, completely natural, should we stop the production of peanuts? Should we stop the production of shellfish? I say fuck no. I love peanuts and I love shrimp. But if you're dealing with a medication that does the exact same thing and reacts with the biodiversity of the exact same percentage of the population and could potentially be fatal, like shellfish can,
sure,
like peanuts can be fatal. People have died from them. What do we do about that?
Yeah, and this is actually
it's a dilemma, right?
Well, it is, but in a way, it's a dilemma that this kind of transgenic or GMO technology can solve. What's really interesting about that is we know what the food allergen proteins are very well. You know that the protein in peanuts, the proteins in soy, the proteins in wheat that cause allergies, and you can turn those off and make them go away using transgenic technology, and it's been done. We have allergy-free peanuts in the lab.
So there's peanuts that people, are they commercially available?
No, because people are afraid of this stuff. This is what kills me.
Oh.
Here we are making solutions. There's wheat that still makes decent bread, where the gluten and the glutens, or the gliadin and the other one, glutenin, have been shut off. it still makes decent bread. You have soy that you can decrease specific allergens. We know what the allergens are in food and can turn them off. And sometimes it makes the plant a little different or makes the product that, like the wheat, when you take out the major glutens, it could change the bread structure. But it still seems that the other ones kind of ramp up to compensate. So we can make a better product using this technology, and they exist. I mean, these things exist, Joe. They're not some wild fantasy of the future. It's just that they would never be deregulated because of the costs and because the industries associated with them. The peanut industry says, no way. We don't want people boycotting peanut butter. Just have a few kids, have problems with the allergy instead. To me, that's a total injustice. That drives me crazy.
So you feel like this could all be eradicated. But in nature, these things are eradicated in a much more disturbing way. In nature, the people that are allergic to peanuts eat them and die, and it's no longer expressed in the genetics. That's the natural method of doing it. The concern with any of these genetic modifications to the layperson, which I am most certainly lay, is that you are creating something that shouldn't be there. That you are creating something, and you don't know the consequences of this, like the wings of the butterfly that create the hurricane. That stupid fucking, that shit drives me crazy. That's not how a goddamn hurricane is made, you assholes. Well, butterflies don't make hurricanes. Shut the fuck up. No, it's a chain of events. It's not. No, it's a fucking weather system. It has to do with the planet. It has to do with the atmosphere. It has to do with magnetics. It has to do with a lot of different shit. It doesn't have to do with butterflies.
But see, that's exactly it. We can sit around all day and talk about, well, what are the unintended consequences? And you get this all the time.
Right.
What if?
Right.
And I can tell you that today, on June 4th, 2015, 20,000 people are going to die because of insufficient nutrition. That's a problem that I can tell you exists. I can tell you that kids will have allergic reactions to peanuts here. I can tell you that there are 60 million citrus trees dying. And these aren't problems Monsanto is going to fix. These are problems that I need to fix, that guys like me, people like me need to fix. And we're being handcuffed by an irrational fear of a good technology.
And do you think that this irrational fear of a good technology comes about because of what they consider to be a greedy corporation? So this fear of greedy corporations, because like we talked about with GM, I mean, we could talk about other corporations that have moved into countries that are poverty-stricken and taken over and abused their natural environment, and that we associate money with, especially corporate entities, with this idea of constantly needing to make more money every year to justify what they're doing to their shareholders. I mean, this is the reality of these businesses, these infinite growth businesses. And we associate them with callousness. We associate them with not caring about the people who work for them or the people that they affect in the environments that they build their plants. And this is one of the main concerns that people have, is the diffusion of responsibility that comes with being a single piece of a large entity that is ultimately doing at least some bad. Right?
No, I understand that. And in the old punk rock guy in me says that
wait a minute, hold on, slow down. You were an old punk rock guy?
Yeah, I played guitar for Insane War Tomatoes for a while. Yeah.
Insane War Tomatoes? Dude, sing me a little Insane War Tomatoes. How did it go? Like,
well, our best ones were called I Rock You Suck.
I Rock You Suck.
Yeah, we had we did a song called Spirit of Elvis, where a giant dancing dead Elvis would come out on stage and
where did you get the name?
I don't know. I know we were called Dangling Units, but then someone already had that, so it's kind of Spinal Tappy. So we were Insane War Tomatoes. We were the coolest band that no one ever knew of.
You have a fucking video?
No. Oh yeah, there you go.
I Rock You Suck.
Oh, that's the song.
Can we hear some of this?
That's oh sure. That's
I live in an asshole. I like how you didn't say the word because you're respectable now.
Well, I am a professor.
I know. What did you do in this band?
I played guitar for maybe the first few years and then switched over to bass.
Did you sing at all?
A little bit.
Maybe a little back up.
Yeah, I think you can hear me coming up right here. I have a little thing here. Coming up in a second here. Kind of Motorheady before.
It's not bad. This is good workout music.
This is me here. Kind of that Kiss.
That's where you jumped in there?
And then here.
That's you?
Yeah, that was me. Yeah.
What year was this done?
This was 1989, maybe 88.
How old were you back then?
I don't know.
How old are you now?
22. I was 22.
How old are you now?
48.
Yeah. Okay.
Yeah.
that
So
makes sense.
we played all over the place. We did a lot in Wisconsin. We were real big, and we had the costumes. We had like I had a Gene Simmons outfit that I wore with gigantic high shoes, and
Wow.
the guy who was the singer dressed as a tomato and lit himself on fire, and it was before Great White.
Wow.
All homemade gas pyrotechnic show.
Oh, Jesus.
It was fantastic. And the 8 people that came to see us loved it.
You got 8.
Oh, we got 8, and they were all.
Right.
And the best part was we would pound our audience with produce at the end. We'd throw tomatoes at them.
Were you involved in agriculture back then?
Not really. I haven't even been until very recently. I was a basic scientist. I studied the nuts and bolts of DNA and nuts and bolts of plant physiology, and.
But at this time, if you're 22 back then, you presumably had gone to college already. And were you studying agriculture? Like, what was the connection to tomatoes and people throwing vegetables at you?
Oh,
was that just luck?
No,
just coincidental.
It was cheaper than throwing jars of pickles. It was,
But you know what I'm saying?
No, I know
like,
what you mean.
Produce was involved in even in your punk rock.
So we've gone full circle.
Yeah, it's odd.
No, I didn't have an that's a coincidence more than because
it's a funny one, isn't it?
Well, it's a good thing I didn't want to study reproductive physiology. I guess
there you go.
Throw ovaries at the. But
that would be the best thing they could throw. I would think dicks.
Yeah,
but still.
But going back to answer your question, so the guy in me who doesn't
Right.
who hates his cable company, who hates his the people who sell him gas, all that
Right.
stuff. I look at companies like Monsanto and others as being the way that farmers who are my real clients are enabled, and. So whether or not I like who they're buying it from, they're the folks who are the ultimate beneficiaries of the technology. And the other thing that's really and so the other exciting thing for me is when the small companies can use something like GMO technology to gain a unique market niche, like Okanagan specialty fruits. They make this apple that doesn't turn brown when you cut it, and they have 4 full-time employees.
Are they from Oregon?
They're from
is that Washington State?
Canada. Canada.
Okay.
Yeah.
What does Okanagan mean? Is that a location or an Indian word? Or something?
Yeah, I think it's both. I think it's
okay.
But they have this apple that when you cut it doesn't brown, which is a great trait. It uses an apple gene to turn off an apple gene. And in other words, the GMO modification puts this gene in backwards so it shuts off the innate construct, the innate gene. It turns off that gene, and then the apple doesn't brown when you cut it, which is a great trait if you want to have apples in processed products, or apples as sliced apples in bags or whatever, for full-time employees. So my whole thing is, go ahead and hate your Monsanto, march against them, whatever, I don't care. But do you realize that when you dress like a bee and lay on the ground and go into convulsions and say that this is biotechnology that's bad, that now you're affecting the people who would buy that apple, the people who I would come up with a solution for the people who need bananas in Uganda, or the people who eat rice in Southeast Asia that need a more nutritious rice. That by mixing together biotechnology and agriculture and conflating that with companies and things companies did or didn't do, you automatically take technology out of the hands of the people in the solutions that we care about. Things like the environment, things like farmers, things like the needy. We have those solutions. And that's the thing that why the Monsanto phobia is dangerous.
Well, I think a good part of what the problem is, it can be attributed to the idea of people not being responsible for actions because they're part of a collective group being completely unnatural. And I think that if people had if the idea of a corporation was not that corporation would be immune to the actual people being involved in that corporation wouldn't be immune to responsibility for everything that the corporation does. That's one of the reasons why businesses get an LLC, right? Limited, whatever it is, corporation. The idea is to protect you. Somehow or another create some sort of legal definition of you that's different than you outside of a corporation, which is weird. It's like people... You're a fucking dude, okay? If you're a dude, if you call yourself Kevin Folta LLC, I'm still talking to you, man. You're right here. You're the same guy. But if you do something under the guise of your corporation, there's a completely different legal ramification than if you do something on your own, like bankruptcy, things along those lines. You're not as responsible for debts. I think that might be the problem. The problem might be, like, I know that you're a decent person and a nice person, and I know that what you're trying to do is noble and just and true and in the vein of science. I 100% believe that. I think that what people are worried about is when someone like you gets to working for some big giant group. This is why people keep saying that you're some sort of a shill, or that other folks, let's say, take you out of the equation. Other folks that are working for Monsanto, they're doing and they're making money, but the corporations give a fuck about people. That's what we have to stop. We have to stop this idea that a bunch of people together collectively can do something that's really unethical, and they can do it and ruin natural environments and not be responsible, like the BP oil spill. Sure. I mean, everybody knows there was all kinds of fuckery and shenanigans that went on to protect the people that were involved from that BP oil scandal. Those people that had been profiting in insane, sacrilegious amounts of money for a long period of time. When it came time to pony up that money and clean that fucking mess up, boy, did things get weird. You know, boy, did things get legal and complicated, and people were given non-disclosures to sign to make exorbitant monies for cleanup, and people were paid off, and there was a lot of fuckery involved. That is what people are worried about when it comes to genetically modified foods. What we're worried about is the method of action that corporations have been proven to take. That is to protect the corporation as a unit, and to do so and act collectively in a way that you would never act as an individual.
No, I agree, Joe. But I guarantee you that 90% of the people that went to march against Monsanto drove a car that used oil that may have came out of a BP well.
Sure.
And so here's an example, though. Go ahead, hate a corporation, but they're still using the products. And no one's trying to shut off, no one's going to the gas station and knocking the pump out of my hand when I go to stick it in my car. Yet there are people who would feel very comfortable depriving farmers of the right to buy the seeds that they choose. And to me, again, if there's a social business issue here that needs to be remedied, there's got to be another mechanism to do that. And I'm fine with that. Go ahead, hate any company you want. All I'm saying is let's not put out the bullshit that says that GMOs cause cancer, GMOs are causing autism, that the herbicides associated with it cause autism. All of that is crazy talk that takes us out of our problem-solving mode. It distracts from the good things that we can do with technology.
What is collectiveevolution.com? Is that a reputable website?
Not so much. They're one that has they're also one that isn't really excited about biotechnology and other corporate stuff. I mean, like Nation of Change, there's a whole bunch of them. And I read those things, and I would say 50 to 60% of the stuff, I'm right there with you. You know, I'm politically a lefty. I'm a college professor. You know, I love seeing social justice. I love seeing social progress. I love those it's stuff that I fight for. But these are examples where I see that technology that can actually enhance those things, and that we can wrestle it away from the big corporations if we only stop fabricating information about them.
Yeah, well, obviously this doesn't have anything to do with social justice or anything. But this study linking GMOs to cancer, liver, kidney damage, and severe hormonal disruption in rats. Right? That was one that Collective Evolution had written a story about.
Well, they covered it just like everyone else did.
And what was the study, and what's wrong with this study?
Well, I think they're mixing together two different studies there. But the main one was one done by Seralini in 2012. And they used a limited number of rats, which are called Sprague-Dawley rats. They're rats that are good cancer models because they're prone to cancers. And so as you're testing different compounds against them, you'll have a model which is at least susceptible to developing tumors. And so if you're testing the toxicity of different compounds, you would use this rat strain. The problem is that by 2 years into the study, 75% of the rats have, or 77% have tumors. So Seralini chose this to do a 2-year study. He showed that the rats got tumors. And in the paper, they even show in Table 2 in the control aisle that even the controls got tumors.
They got the same amount of tumors?
Well, statistically, yes. I mean, they showed fewer, but they talk about they talk about 5 versus 8 versus 9. Statistically, the numbers were too small to say that was a significant difference.
So when you say 5, 8, or 9, you mean percent or mean
number
out of how many?
20.
Okay. So that could be just an issue with the particular group of rats you had, as opposed to you would have to do a much larger study to get a good baseline. Is that what it would be?
It was in the statistical noise.
So 20 rats seems like a real low number to test things.
Well, it was 200 overall, but it was broken into groups.
They all quit.
So screw
Fuck
this
study.
But the main thing in this, though, and the place that really colors it for me, and I don't know, do you have the picture of the lumpy rats on your screen?
No, I'm sure it's in here
But you know the famous picture of the three lumpy rats. Note that the authors show 3 rats, one that got GMO food, one that got Roundup, one that got GMO food plus Roundup. And they call it GMO, by the way, which scientists would never do. We'd put in the transgene name. They neglect to show you the control rat.
And the control rat got fucked up too.
Well, a significant number of them did. But if you show, but I can, what do they do? You know, how do they show that picture of these rats that are grotesquely malformed? Which, if my lab let rats go to that, yeah, there they are. If my lab let rats get to that stage, or any lab in the United States let their rats get to that stage, they'd be shut down. That's animal abuse. It's inhumane treatment of animals.
Is it? Well, I mean, that's something that I feel pretty strongly against. I really severely dislike the idea of testing things on animals in the first place, but it seems that that's where a lot of the big improvements in medicine have come from. It's a real moral dilemma. I mean, I think using animals, especially intelligent animals, like I saw a fucking SeaWorld commercial this morning. They made me want to throw a mug at my TV. They were talking about how happy these whales are in a fucking swimming pool. And this guy's like, our whales are happy and we love them. I'm like, fuck you, you do. We haven't stolen a whale from its family in over 30 years. It's like a slave colony telling you how these people have been born slaves. Don't worry about it. They're happy being slaves. We love them here. If you had that exact same goddamn SeaWorld commercial and you had it about human beings, you would those people would be thought of as some of the most evil fucks on the planet. But they don't think of orcas as human beings, even though they have a cerebral cortex of 40% larger than a human being's. Even though they have dialects, they have a bunch of different words for all sorts of things. We don't even understand what they're saying. They have super complex methods of communication. They're very human-like. They just don't alter their environment. So because they don't alter their environment and they can't smile at us, they don't have articulating lips, we choose to think of them as being inferior to us, and it's acceptable to have them in a fucking swimming pool. You know, and I think that's dark, and I think that's really evil. And I think one day when we figure out a way to interpret what they're saying and have like a Google Translate for killer whales, it's going to be a mess. And the SeaWorld, they're going to go to jail immediately. I don't even want to watch it, man. It's fucking horrible. We love them. Fuck you, you do. You don't love them. If you loved them and they were people, you'd let them go. Figure out a way to let them go, you fucks.
I even look at zoos when I go to zoos, and you see that cheetah. Oh. This damn thing is supposed to be running 75 miles an hour after an antelope, and it's sitting there laying on a shelf.
Exactly. And all its reward system, its genetic reward systems, are they're not satisfied. Like a lion killed a woman at the woman who was a Game of Thrones editor. Did you hear about this? She was at a safari park, and the fucking hard irony of it is she's a conservationist. She loves these animals, and she wanted to take photos of them, and she wants to protect them from poachers, and she left the window open. The fucking lion got her, jumped in the cage, jumped into the car and pulled her out and killed her in front of everybody. And it's horrible. It's a horrible, horrible thing. But that's what lions do. I mean, that is their reward system. That's why they're here in 2015. They have a predator-prey reward system. And that reward system isn't being recognized at all in zoos. That's one thing, one aspect of their life. It is probably as satisfying and as primal as intercourse is to them. And they're not being allowed to express it. And that's a fucked up thing. I mean, zoos are, I don't care what anybody says, they're doing all this great work, they're doing all this great work. They're doing it the wrong way. They're doing it the wrong way. You know, it's just, you can't lock a monkey in a fucking cage and people just stare at it. That's got to be torture for that little thing. There's a monkey at, I think it was the Colorado Zoo, the one, I think it was Colorado. I forget which zoo. It might have been the one in Griffith Park, but whatever the fuck it is. There's a monkey that was howling like a madman. He was just holding onto his cage going, "Wah!" Just screaming into the night. And you're like, tell me that's any different than some guy in a psych ward who's trapped and aliens with giant fucking watermelon-sized eyes are staring at him all day. How is that any different? It's not. No, it's not.
I agree. I mean, I have a hard time with, especially with mammals. Like I choose not to get involved in that. I know there's, educational aspects of, zoological collections.
Right?
And, turtles, maybe I don't freak out so much about.
They don't seem to give a fuck.
No, they kind of like it. I mean, it's like food, water.
Well, their brains are that big.
Yeah, that doesn't seem to get too weird. But
you get into chimps and shit.
Yeah, even big cats. You just see those things, bears.
I had a joke about it, though, that some animals, the zoo doesn't seem to bother them, like giraffes. Giraffes don't seem to mind at all. Like, they let them feed babies, because the joke was that the giraffes are like, another day with no lions. And like, if somebody came up to a giraffe and said, listen, man, I'm going to give you free food. There's going to be no predators whatsoever, but you can't walk as far. They'd be like, well, fuck yeah, let's do this. Because the giraffe's life is goddamn terrifying all day. So for giraffes, the zoo doesn't really seem to bug them. Like, especially if you go to like San Diego, which has an awesome wildlife park. It's huge. Like, as far as zoos go, that place is top of the food chain because that place gives them enormous spaces. But again, the predators aren't allowed to express being a predator. There was an Iraqi zoo footage. See if you could find this. They let a goat loose in an Iraqi zoo. And this is how they feed their lions. Oh, jeez. And soldiers, this is how soldiers film this at the beginning of the war. And they just have a goat. And the goat, it's fucking Jurassic Park. The goat is just let out of this gate, and the goat walks up, and the lions realize that the goat is there, and then, whoom, they're all on him, and they tear this fucker apart. Yeah. That's how zoos are supposed to be. That's what a goddamn zoo should be. Oh. What we're doing is bullshit. You give them a plate of meat.
We were at a zoo in Portugal. My wife and I were there a few years ago. I was there for a conference, and we went to their zoo, which is a really nice zoo in Lisbon. And one of the monkeys, they're a big cage full of monkeys, like 1 million of them in there. There's like 30 or 40 monkeys in one cage. And then one of them comes out between the bars and starts walking around. They just came out of the cage. Wow. Start walking around. It was pretty funny because all the parents are letting their kids touch it and stuff.
Oh, Jesus Christ.
It's like bad primate decision,
Yeah, that's a shit. Yeah, you're the dummy, not the monkey.
Nope.
Here it is. Look at this. These goats, they just open the door and they let them out, and then they release the lions. They open this gate, and the lions just come charging in because they know exactly what the fuck is going on. And, I remember people watching it saying that it's cruel. The reason why you think it's cruel is because we have been sheltered in some weird way to think that our way of living should be imposed on animals. And that's crazy. That's crazy thinking. The idea that you should give look at this. The lions just jump out and boom, they take these goats down. And they all jump in. They all know what they're doing. This is what they do every day. And this is how they eat. But the idea that this is somehow brutal, God damn it, this is what it's called being a cat. This is what cats do. What you're doing is brutal. By giving them pre-cooked meat, you're not allowing them to express this charge that they must get, the bond and community that they generate together because of killing and surviving off that kill together. Human beings have it, and I guarantee that lions have that as well. And you're not allowing them to bond in the same way. This is a part of establishing the pecking order in the communities as well. Who's the better hunter? Learn from that hunter. Look how he bites that neck. They all learn from each other. The mothers teach the babies how to fight. They teach them how to trip things and chase things. They play with each other. They trip each other just like they want to trip game. And we don't allow that. It's fucked.
No, nature's cruel. I mean, it's the way it works, and
it's more cruel to not let them express their nature. Mm-hmm. This idea that you feeding them an animal that somebody killed nowhere near the cat is somehow or another more ethical than letting the animal kill the cat or the cat kill the animal is preposterous. It's just fucking idiotic. It's a crazy picture. This video, rather. It's just that's what they do, man.
Well, don't say the Iraqis never gave us anything.
They gave us a little bit of that. But do you think that there's an ethical way to do tests on animals that would satisfy everybody? Almost, is there a way? I mean, what ethical way would there even be?
Yeah, I think, and I think we have to go back, and this isn't my area by any stretch, but animal testing is a really important part of biology and really important part of pharmacology. When you look at how animals are used as drug models, like right now we have animals like mice that express or don't express a gene associated with brain function that we know is impaired, say, with ALS in humans. So essentially we have these mice that will develop ALS. So now you can use compounds to see what solves that problem. you can build these models, or cancer models are many in animals, where you have these animals that are predisposed to specific kinds of cancers or ailments that now allow us to do tests to find them. And I think that's a really important role for this, that animals can help us identify problems that help the human condition, which then can help us help animals.
Is there a way to do it, though, that's going to make everybody happy? I don't think there is.
No.
I think it's one of those things that we have to say we're better than you.
Well, or that we have to say that these are that this is it's just like when we raise animals to eat them, I guess. I mean, there's a purpose for these animals that we bring them into our provision. We raise them humanely, and and these animals that are in these drug experiments, by definition, have to be very carefully. They have to be happy. They have to be as happy as you can be, as a rat in a cage.
How would you know that a rat is happy?
Well, because there's physiology that's involved. And if you have rats that are living in conditions that are subpar or animals that are mistreated, they won't give you adequate results from your experiments. So you need to have incredible control with animals that are well cared for and give you a solid physiological baseline where the only information being introduced is through your treatment.
Do you know what being a speciesist is? Have you ever been accused of being a speciesist?
I got a feeling I will be shortly.
This is speciesist thinking, the thinking that you and human life is more important than other animals.
Yeah, no, I don't know if that's necessarily the case that we're more important, but we certainly have more faculties to be able to control the outcomes of certain situations.
Right, but if rats were smarter than us and they decided to do tests on humans, it would really suck, wouldn't it?
Yeah, so screw them.
But we're not very smart, right? I mean, we're very smart for other animals, but we're not very smart in terms of there's a lot of shit that human beings do that we probably shouldn't do collectively, like pollution, destruction of the environment, so on and so forth, proliferation of nuclear weapons. That's not smart. There's a lot of stupid shit that we do. So I think that we're incredibly smart for being an animal, but we're not necessarily smart in terms of the universal potential of intelligent life. We're not. We're idiots. That's why, I mean, there's a million fucking arguments you can make all day long. The gay marriage thing, the marijuana thing, the war thing. There's just so many stupid contradictions the way human beings exist and live their lives. If there was something that was far more intelligent than us, like as intelligent as we are to pigs, or as we are to things that we think are smart, like dogs are fairly smart, what kind of test would they do to us? You ever think of that?
No, I never really think about that very much. I guess I am a speciesist.
There's only one way to get that smart. You got to fucking keep fucking pigs and.
But I think the idea,
with needles and shit.
The main idea is that we've evolved as a species for a long time away from our common ancestors, other primate ancestors, because of our ability to control situations and because we make decisions that end in more favorable outcomes for whatever reasons those are for us. And so even though we do a lot of dumb stuff, and I'm with you on that, I think we do an awful lot of smart stuff too. And I think the human capacity to create change that's favorable for humans is immense.
Maybe you can do your own documentary. You know how Al Gore had that one? The Inconvenient Truth? How about The Uncomfortable Truth? The uncomfortable truth being you got to crack some eggs to make an omelet. And there's a lot going on to try to keep human beings alive, and sometimes you have to make a decision. I forget Nick DiPaolo, one of my buddies, hilarious stand-up comedian, had some joke. I don't want to fuck the joke up, but it was about doing tests on a monkey to find, to cure AIDS, and it was fucking hilarious. But I don't remember how the joke went, but it was something about battery cables, and it was very funny. But the idea being is like, yeah, I'm saying I'm more important than a monkey. I'm saying my mom, who's dying of cancer, is more important than a rabbit. I'm saying that. I'm saying that a rat is not as important as my children. I said it. Sorry. I'm a speciesist. No, but
and I think that human progress has shown that sometimes the pendulum swings a little bit too far the other way. We can think of examples.
Sure. But yeah, I mean, as soon as you look at, instead of whether it's money or the results being more important than the actions of the individual, and the actions of the individual not being ethical, that's not being important. What's important is the results. That's when we run into problems.
Yeah, but that's
right?
and so even to circle it back, then, this is why being a scientist is so cool, is because I'm bound by data. and I'm bound by a hypothesis that I test using the best available tools. And being a public scientist is really cool, that the people who choose to do this like me, and there's a lot of them in this country, we are really operating in the public's trust and the public's best interest. And I think that when we see unethical behavior, when we see, let's say, interpretations of data which suggest that maybe we're going the wrong way, these things are caught in the peer review process. These things are caught when our grants are evaluated, and they're debated in the scientific literature. And so when we're making steps in progress, these are very careful, guarded, reviewed, re-reviewed steps that we're doing as a public science enterprise. And this is what's why I wish we had more support. I'm not here to complain about that. I wish and that, people say that, oh, you're from Monsanto. We get nothing compared to what they have. I mean, we're, as a university, we get something like 3% of our support from corporate entities. Everything else comes from grants that we go out and get. And so this is what's so important about having an active public science enterprise, is to keep all that other stuff in check.
I think it's also important to try to understand the whole process that's involved in science that the average person who doesn't have a background in it, the average person who didn't take science other than the classes where you dissected frogs in high school, they're ignorant of the process. They're ignorant of the process that creates this data.
Mm-hmm. And they don't understand where we come from and what we go through. If you talk to anybody, they'll tell you, well, universities are just paid off by the companies, and the companies.
But sometimes that's the case, right?
Well, universities do have contracts frequently with companies. It happens all the time, but that's because we're the experts.
Well, in other fields, it's a much bigger issue. Financially, like, it's been a big issue in the setting of regulations for the stock market and things like that. The people who did it at university, you know what I'm talking about? Those economics professors who made recommendations and then wound up getting these huge jobs with the banks after it was over for millions of dollars.
Yeah, and that's wrong too, though. And I think what's really important, though, is that a lot of the companies, pharmaceutical companies, will come to a medical school and say, we need you to do this clinical trial because you are the experts. You're the ones who know this. We trust you, and if it doesn't work, you better tell us. No one's giving us money to make them happy. No one's telling me, and this one pisses me off all the time, because out of everybody you meet in science, there's so many of us that really do claim to have integrity as a first level. I would never do something because a company told me to do it or because a company paid me to do it.
The punk rock in you would not.
That's right.
You fight that power.
No, I fight the power. No, because seriously, at the end of the day, I'm not a religious guy. I don't believe that there's some great reward for me. What I'm leaving here is a legacy, like a product of my work and my record, and I don't want that tarnished.
I believe you 100%, and I'm certainly not questioning that. I want to tell everybody, the thing I was saying about mathematics professors, you should watch a documentary called Inside Job, or An Inside Job. It's all about the financial crash. It's fantastic. It's really, 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 really well done. It documents that. But people aren't worried about people like you. You seem to be a great guy. What they're worried about is evil scientists. That's what fucks up every science fiction movie.
Yeah.
Did you see 28 Days Later?
No.
28 Days Later is one of the greatest zombie movies in the history of the known universe. My personal favorite. Starts out because of medication that was created, something called rage. I forget why they created it, for soldiers or something like that. But it infects these chimps, and then these chimps get it. They bite people. The people get it, and then the zombie outbreak takes over the world and kills everybody except for a few cool people.
Human caterpillar.
Yeah. Well, this that's different, but this I think you mean centipede.
Or human centipede, yeah.
Don't watch that. Don't. That's different. Now this is a fucking awesome movie. Human Centipede was a goof.
Well, it's scientist.
Fun.
Evil scientist.
Yeah, but he was an evil scientist. Yeah, that's a good point. But 28 Days Later was about a medication that they had intended for human beings, and it went terribly wrong. Well, that's the kind of scientists that people are worried about. People are worried about the evil people that are creating. I mean, look, there have been scientists that have created weaponized drugs or weaponized biological weapons, rather, that they can use on people, certain gases. I mean, those are created by scientists, like poisons that have killed untold numbers of people were also created by scientists. So
absolutely,
it's not just guys like you. People are worried about people that are way fucking smarter than them that might be plotting some evil shit.
Yeah,
because it's happened.
Well, it's happened, and then you look at, and the people always bring up in the GMO discussion, Agent Orange.
Yes.
You know, which is an herbicide called 2,4-D. And a number of herbicides were combined, and there was this whole rainbow of herbicides. They call it Agent Blue, Agent Green. Agent Orange was this 2,4-D stuff, 2,4,5-T. They're what they call synthetic auxins. They make plants grow to death, basically. And the government was able to weaponize a legitimate product for warfare. It had nothing to do with an evil scientist necessarily, but it was implementation potentially by people who had an agenda to be able to expose an enemy in a jungle atmosphere. Along with the purification of those products, 2,4,5-T was the main one, was dioxin, which is what killed people and harmed our own soldiers.
That is one of the scariest things about human beings, that we're willing to kill your whole forest to find you. I mean, just stop and think of how fucked that is. We're looking for him, man. We can't find him. We're going to kill everything. We're going to kill every fucking tree, every bush, everything. We're going to kill the whole forest and flush them out.
Yeah, the daisy cutter, you know, basically, you know, the chemical daisy cutter.
God, that's so crazy that someone okayed that. Someone said, yeah, you can ruin the entire ecosystem. Yeah, go there and kill everything that moves so that our boys can go in there and kill the people that are hiding in it.
But this is an interesting example that here you had something that a really great scientist came up with. Arthur Galston came up with 2,4,D to control plant growth and control weeds. And it's a relatively useful compound that we've had for 70 years. But yet people will say you're using Agent Orange on corn. You know, we're not using Agent Orange. It's a growth regulator that was part of Agent Orange that humans decided to weaponize against other humans.
So that was created first, and then human beings took this and said, well, there's some sort of a weaponized application of this very beneficial discovery.
Right, and a compound that can be used safely in an agricultural context and has been since the 1940s.
See, again, it's not people worried about the scientists. They're worried about the evil people that control the scientists and take that stuff and turn it into this and then spray it in Vietnam.
Yeah, but we can't go forward worrying about the small number of evil people that might be out there, because they're going to do it. There's always going to be some guy who finds a way to sew a bomb into his underwear, but that doesn't mean we outlaw underpants. You know, we could. But the idea is that we need to think about what the science allows us to do, and not worry about certainly be aware of malevolent uses. People could genetically engineer viruses, and I believe I've heard about the Russians doing this back during the Cold War days, to say engineer a antibody that would attack human myelin, which is the stuff that covers your nerves, so that you could essentially infect people with a virus that would kill them because it would paralyze them.
Whoa.
These kind of things were discussed, and biological agents and biological weaponry is there. But as it has power in that dimension, I think the main conversation here is really how do we take the same technology and use it for good?
Essentially, what we're talking about is really what I was saying before, is that I think a lot of your hate comes from people that are terrified that they don't understand what's going on, you know, and that's me. I fit into that. But I ask a lot of questions, and I trust you, so I go, all right, it seems to make sense. But realistically, when you're talking to me about the expressions of genes, my brain is just going, those are a bunch of noises that represent some things that I don't totally understand.
Well, let's talk about things that we can talk about.
No.
I got some good ideas.
I'm not saying that there's anything wrong with it. It's great.
I guess I'm kind of giving you an opportunity to say, what are things that you care about that I could fix, or scientists could fix? Like, what are some concerns about food that you the interviewee becomes the interviewer. What are some things that you would worry about in terms of food, or maybe food abundance, or what would you like?
Food abundance is always a big concern for everybody, especially when you look at parts of the world where you see these. Like, I have a good friend named Justin Wren. He comes on the podcast, and he used to fight in the UFC, and now he works in the Congo building wells. He's an amazing guy, and he does this thing called Fight for the Forgotten, and he goes to the Congo, and he did it with some money that viewers generated too. They built a bunch of wells that listeners of the podcast generated through Bitcoin, and then I matched the donation, and he built these wells. This guy's dedicating his whole time to doing that, to giving these people clean water. Like that, I think, mean, that's not even scientific, other than the ability to. I mean, somebody obviously had to invent these water pumps and filters and figure out how to make these wells portable and functional. That's really what needs to be done. We need to figure out a way to take the worst parts of the world and bring them to a higher standard of living, and give people the opportunity to not live on dirt floors where they're drinking muddy puddle water. Yeah. You know, I mean, the fact that it takes a guy like Justin to go down to the Congo and dedicate his life to that, and a bunch of other brave people that are doing the exact same thing, but that countries never talk about it. They'll talk about all sorts of issues that are going on in the environment, all sorts of things about what happens if the ocean rises and we lose Malibu. You know, like everybody's freaking out, but no one's freaking out about these poor babies with distended bellies because they're filled with parasites. This is a huge human issue. And if they were white people that looked like they were from Norway and this was their problem, if they were all beautiful people that looked like they're from the Game of Thrones and they all had distended bellies, everybody would be freaking out. They'd want to go over there and save those folks. And it's one of the more disturbing and sadder aspects of humanity. I don't know. I mean, science can help certainly with medication, with antibiotics and antiviral drugs to help these people that have all these parasitic infections, which is incredibly rare in these tropical rich jungle environments. You know, that's, I think, would be the thing that I would look forward to the most to fix the world and stop this whole killing other people shit.
Well, let me. This is really a perfect example. I'm glad you brought that up. Especially with Uganda, with Congo, because Uganda is one who I just met a scientist this weekend, and he's a plant breeder by trade. Who he said. Here in the United States, everybody is screaming that they want choice. They want GMO versus non-GMO. He says, over by us, we just want food. And a very sincere man who is desperate for solutions for his country, and I'm going to work with him. And there's three things that could really help Uganda right now, and that they are actively on the ground there. Three solutions for problems they have. They have something like 70% of their calories or carbohydrate calories come from bananas. And not like bananas we have, but African bananas. And bananas have two problems. One of them, well, two pathogen problems. They get what's called xanthomonas, they get Phytophthora. There are genetic engineering solutions that are in place that can solve both of those problems. There's also an issue that people there have vitamin A deficiency, so they're going blind along this golden rice line. You're looking at 250 million to 500 million blindnesses a year. Most of it in kids, and half of them die within a year.
And it's all because of a vitamin deficiency?
It's because of vitamin A deficiency. Oh. And now they have bananas that have the genes from a banana that produces vitamin A that's kind of agriculturally useless, but they move those into the production banana from the Congo, and this is, from Uganda. And this is a Gates Foundation sponsored stuff, and other people have done this. So now they have a banana that produces vitamin A, or well, beta-carotene, which is converted to vitamin A, and then resistant to the two main diseases. And it can't be used. And you've got Greenpeace and other activist organizations on the ground there fighting it. And they're telling people that this is just the Westerners coming in to take over and give you the food and the technology they reject, saying that it'll cause sterility.
Who's resisting like this? Who's
These are very wealthy Western-funded organizations that are opposed to genetic modification. They know that if Uganda develops these products and is allowed to give them to their people, and they solve a problem, that now the house of cards in the Western world falls down.
So you really believe that there's a conspiracy to keep these bananas out, because if the bananas go through and do good, which they think, you think they will for sure, the science says they will, and that these people think it will as well, and it will open the door to genetic modified foods going into these countries, and they'll lose the battle. So because of that, they're willing to sacrifice these people getting this vitamin A rich banana? Really?
It's not a conspiracy.
That sounds very conspiratorial if it's true.
It's clear as day. These in China, they tell people that it'll cause infertility.
Well, that is a conspiracy. Wouldn't you agree?
Well, I guess a conspiracy is an arrangement of. I guess that is a conspiracy.
Well, it's unethical and it's untrue, right?
It's something that is but it's very transparent, is what I guess I'm going for. This isn't some secret clandestine operation. This is something that is very well understood that this is what they're doing.
But to play devil's advocate, isn't it possible that they really truly are concerned that a company like Monsanto would get their monetary hooks into a country and start fucking around there and doing a bunch of unethical shit.
Sure.
That's what they're worried about.
And I think that's something that they would be worried about. But let's not
throw the baby out with the bathwater.
Well, no, let's not accept phantom fears for real fears. We got people that need problems, and let's not say, well, maybe Monsanto will be involved, so let's not allow it. Let's let them use the best technology. And are
they trying to license this technology and profit from their use of it?
No, what's so funny about this is that these are laboratories there that said we want biotechnology, and they're developing their own labs and their own stuff. This professor I met this weekend, I'm going to go there next year to help him set up a lab to grow coffee in culture, not GMO coffee, which is maybe an interesting idea. But their issue is that they can make a tremendous amount of money by growing coffee for farmers. Farmers can grow coffee and have a very profitable operation, but you can't grow enough plants of the types that are resistant to the diseases. And so we're going to help them do that in tissue culture, where we can propagate tens of thousands of plants very quickly in a jar rather than by seed. He's actually going to sponsor a student to come to my lab to do that, and I'm going to go there and help him. But this is the kind of place where you can solve a problem with this kind of technology, and where we're being blocked. And to me, as a scientist, I think of the 20,000 people who die. I talk about it when I give talks, and I can't help but get tears in my eyes when you think about the malnourished people I've met in my travels who changed me. You meet them one time, and especially when you shake their hand and feel how weak and small they are, and you dedicate yourself to how you're going to fix it. And to have people say, well, it's all Monsanto, it's going to give you cancer, all this stuff that's not true, you block the investment in technology and the application of technology that can help. And so when we have this kind of conversation, I think about the allergy-free peanuts. I think about the golden bananas, the golden rice, all the applications we have. There's countless, and we can't use them because of a fear of the technology.
And you feel just an ignorance of the technology.
And an ignorance of biology and genetics.
But you also think that they have to be aware of this, too, in order to make this grand conspiracy to try to keep this illegal, to keep this out of this country. They have to be aware that they are preventing good. They have to be aware.
Yes.
I mean, so that's kind of fucked up.
Yes.
And to be on the good side.
And
supposedly the progressive side, the rightful side, the side but everybody wants to support anti-GMO causes. Everybody is terrified of GMOs.
Yes, and that's why. And the reason for this has been you talk about the companies that do it. They totally failed when they rolled out this technology. They didn't say, here's how it works, and let's take care of your fears. They rolled it out and said, here's what you get. And people equated this with Frankenstein and evil scientists. We didn't get good education up front. Then over the years, there's been a machine of documentaries, books. The people who sell the books and documentaries about the dangers of this, they're the ones who are making the profits. They're the shills.
Right.
They're the ones that if they can make $1 by scaring you with their product, and so they've been running free. Scientists like me have totally screwed this up too, because the first time I talked to a public audience about GMOs 15 years ago, I sat down and I bombed them with science. And I told them about how it's done and details that they didn't need. I turned off more people than I converted. And only in the last 3 years, really have a scientist got together and said, this is a crisis, that our technology can't reach those who need it, and we need to rethink the way that we talk to them about science. And it's not about beating people to death with the science hammer. It's about sharing ideas and things that we all really want, and our solutions that we can use, and really separating a technology that's very good from companies that, good, bad, or whatever. We need to know the technology is good.
Yeah. What do you think initially caused the fear of GMOs? Do you think was there any particular story that came out that misrepresented it, that became viral, or what was it that started off this big fear of this aspect of science?
Well, I think there's always been an environmental movement that has decried the use of any kind of chemicals in farming. And
for good reason.
For good reason, and I understand that, because you got DDT and all these great examples back there.
I know a guy who's got bone cancer, and all these kids he grew up with had cancer as well because they all lived near a golf course.
Yeah.
And the shit that they used to spray on the golf course got into the well water, and cancer was rampant in their small community.
These examples are in, when you go out, I went out to Hawaii to talk to them, and they all talked about, back in the day when they would grow the cane and they would use all these chemicals, and whether the stories are true or not, I think there's a certain level of understanding that we did things differently back then. And we weren't in places like South America. They still do this. If a little bit works, more is better. Here, the regulations are really tight, and how you can use a compound and how it's allowed to be used, and the residues that are present are all very well monitored. And I think that the times are changed. But going back to your question of, where did this come from? I think there was an environmental movement that was certainly on guard, and I'm glad they're there.
Absolutely.
I'm very happy about that. The problem is now that anything that any of their former foes in the environmental movement would produce, Monsanto could have came out with the duck that makes golden eggs, and they would have said the gold is poison. Anything that comes from that company is going to be tainted, just by name. And that's where I think a lot of this comes from. And that when they came out with tomato, and back when it was on the market, or any of the products that they've made, it hasn't been, let's think of what we can do with this, but here's just another way that this company is rolling out a product to gain world domination of a food supply and make money off chemicals.
Well, it's because of what we discussed earlier. Or I should say it could be because of what we discussed earlier, because people have an inherent distrust in folks that are willing to copyright life. The idea that you own the copyright to some corn, and I know that you genetically modified it, I know that you changed it, but what it is now, it's life. And if you do that to a pig, what happens then? If you do it to a pig, why can't you do it to artificial livers? Why can't you do it to all sorts of things? You could all of a sudden copyright an entire human body and own a trademark on human bodies. You could specifically design a type of human that the only way you can get your kid to be alpha beta 16 is you got to get the alpha beta 16 Monsanto gene inside of your kid. I mean, this is not outside the realm of possibility. This is within 100 years from now. They'll be doing shit like that. That freaks people out, that a corporation could own human life.
Well, yeah. It's an interesting, actually, it's kind of a little bit off topic, but they have that now 3-parent kid, where they've mixed the mitochondrial part with...
What in the actual fuck is going to happen with that kid?
Well,
what if he comes out evil? Then what?
Then what? Well,
yeah. What if he's one day they're going to fuck around and create the Antichrist, right? I mean, this is where it comes from.
No, it's an interesting thought, plus you're buying more presents at Christmas for your, multiple parents, or
the kid will.
Yeah.
A lot of burden on the kid.
If the parents get divorced, the custody will be a mess. And
well, what if they disagree with the way they raise the child?
Yeah.
Maybe you have to agree. It's hard for a husband and wife to agree on specifics as far as language to be used, how to handle certain situations. You got 3 people chiming in, trying to be the dad.
Well, the good news is child support will be half the price.
How many dads and how many moms? Is it broken down?
I think it's 2 mothers, because there's a mother that provided the nucleus and a mother that provided the rest of the cell goo, and then the dad just the sperm.
Good luck with all that. That guy's a pimp, by the way.
But the whole idea of but the cool part about this, though, is that we wander into the mad scientist realm again. Let's think of things that have been done that are really positive, and that even our patented technologies. So you got a pig that was made that has a better ability. It has a gene that it makes saliva that breaks down phosphorus better in its food, and phosphate. So what it allows the pig to do is have less toxic waste. They called it the Enviro pig. And it has because pigs, their effluent is a problem, and to keep it out of the environment's a good thing. And so they made the Enviro pig, and the Enviro pig is a crushed idea now. There are only a few embryos left in the tank of liquid nitrogen. They made this week. I heard of salmon, that they put a salmon gene into a salmon to make it grow twice as fast. It was originally developed in 1989. And that the company that's been trying to get it approved has been at it since the 90s. And they've got all of the approval, but it's never been finalized. And the beauty of this fish is it grows to harvestable size as a farmed fish in half the time. So you're using half the stuff, half the food, half the resources to make the equivalent amount of protein.
But what if these fuckers get out into the wild?
Yeah, they thought of that.
They're Hulk spawn trout.
Well, they're all females, and they're triploid, so they have an extra chromosome that makes them infertile.
Yeah, but isn't this how every bad horror movie starts?
Absolutely.
You let one of those things loose, and all of a sudden it becomes like a crocodile man. That's like the creature from the Black Lagoon. But see, it could be a salmon that you guys fucked with. It turns into a person.
But this is but it's so funny because we always spin off into this, and you especially. We're like, we go into this idea that
it's my fault. I'm sorry.
Well, but this is it always goes back to what is the way that this can break bad.
Yes, and that's how I look at things.
And being an eternal optimist, I think of what are the good things we could do with this.
Well, I expect no less from a guy who had a song called "I Live in an Asshole." I would think that you would be the eternal optimist.
It was social commentary from me.
I'm just joking, obviously.
No, I know. We're having fun. Yes. But it is the kind of thing where my job is to sit around and figure out how to solve problems.
Right.
And so when you can come up with a fish that gets to eating size in half the time, which could, in theory, really relieve pressure on wild salmon fishing and put food into the high protein and good food into the hands of people who don't normally afford fish. Like me, I don't buy it.
But see, biological stuff like that scares the shit out of people. It's like, you know what a liger is, right?
Sure.
You just saw Napoleon Dynamite. It's a cross between a lion and a tiger. It's an enormous, enormous cat. It's the biggest cat we know of, right? I mean, I think something happens in the genes. I believe it's a male lion and a female tiger. I might have it backwards. But the gene is for regulating the size of the growth it's not the same. So something happens in the cross where it becomes infertile because it's a hybrid, but they grow to enormous sizes. Like, look at the size of that goddamn thing.
Yeah.
It's some weird genetic modification, but not through scientists in a lab, through just crossbreeding.
Yeah, that's a hybrid vigor.
Yeah.
It's a case that when you mix up genomes that don't normally match.
Look at the size of that thing, Jesus Christ.
Yeah, I wouldn't be grabbing it like that.
Good Lord.
What is she handing it? Meat on a stick?
Some food.
Oh,
yeah.
boy.
Well, you got to keep those things super fed.
Yeah.
Like really, really, really fed. Like, so they don't even think about eating you.
But it goes back to our corn. This is why we have great corn, is because there are two genomes that wouldn't normally get together that humans put together. Mm-hmm. Seedless bananas, which all the ones we have have an extra set of chromosomes. Your seedless watermelon has a separate set of chromosomes. We've been mixing together plant chromosomes in ways nature could never intend for decades. And here you add, with great precision, one gene that we know what it does to a salmon. We can monitor it, we understand it, and it has a beneficial product that can help humans. And they grow these things in tanks in Panama. They can't escape. They're inland tanks.
One of them is going to get super smart and figure out how to crack the safe.
And evolve really quick and get legs and leave.
Dude, I saw the movie.
But see, there's all these precautions that are put in place to make sure that these things can't happen. And of course, we can always think of the example, thalidomide, now you got flipper babies,
Sure.
You can always think of examples where it didn't work, but what we tend to dismiss are the hundreds of thousands of chances of things that worked better than expected.
Right.
The thing that makes your computer grow better, that you can have the equivalent of the Apollo lander's firepower in terms of computational ability on your wrist.
Even more than that now.
Oh yeah, and these are the kind of breakthroughs that we take for granted and we ignore always. But we have to stop worrying about the what ifs and start worrying about the what cans. And that's where I really want to try to get people to refocus this GMO discussion. What are your pressing problems? What are the things that science can do for you today? And I think that's where this gets super exciting.
But you can understand why people are worried, right? People who don't understand the science or it's never been explained to them certainly don't know anybody like you that they could sit down with. Like, if we do this for 3 hours, is that even enough? I mean, it's not really. Like, you could probably explain this shit to me for months, and I would just be slowly working its way into my understanding. But people worry about what they don't understand, and they really worry about human beings, quote unquote, playing God and manipulating genetics and manipulating life, even though that's kind of what we always have done.
Yes.
And there's a great Radio Lab podcast on the Galapagos Islands. It's really fantastic. And one of the things about it is their attempts to keep invasive species from entering the Galapagos Islands. And the plant species were going there from the bottom of people's feet, where they had stepped in seeds, and then they stepped on the grass, and these new species of grasses grow, and pirates had left goats on the land so that they could come back and they have a food source when they would land on the island again. So they had these invasive goat species that were living all through. And they realized, like, there's no fucking way. You can't. Like, everything used to be somewhere else and then made its way across. But when we start monkeying with those everythings, that's when people are worried because of certain outlier examples. When you forget about all the crops that we plant, all of those are totally unnatural, right? I mean, an orange grove is like the most unnatural shit ever. You dug a hole in the ground and put some trees that were never going to be there. And you got a whole irrigation system. I mean, go to Napa and look at the wine vineyards. That's fucking totally unnatural. That shit just doesn't exist. You're never going to walk through the wilds of some uncharted land and find a fucking wine vineyard. It doesn't exist. You have to grow that shit. You have to make that a part of the environment. But sometimes it goes terribly wrong. Like, they introduced rabbits in Australia and they don't have predators. So the rabbits just fucking went crazy and ran through the entire country. Like, they have a huge rabbit problem. So then they brought over foxes. Yeah. So we'll bring over foxes and cats and we'll kill the rabbits. But then those foxes and cats don't just kill rabbits, you fuck. They didn't genetically engineer foxes that can only look at a rabbit as a predator, as a food source rather. They kill everything. So they're responsible for like 30-something extinctions in the entire country of Australia. It's fucked. They have these fucking foxes running around just killing everything. So they're so bad that they have a problem with their sheep, where the foxes are grabbing the baby sheep as they're coming out, which is apparently like standard predator behavior. And this is freaking people out because this is all because humans meddled. You introduced an animal to a place where it didn't belong, then you tried to introduce a predator to compensate for it, and you see this chain of events that's really a problem and a managerial nightmare for people that they have to manage the wildlife down there.
Yeah, but this is so. But all these examples happen, and certainly things do sneak out here and there. You got to go with that. But you know, when we want to talk about releasing a new plant variety, and we're not talking GMO, we're saying, let's say, a new elite strawberry that we know, or sorghum or whatever that comes to our university.
What's a sorghum? Because I like strawberries.
It's a kind of grain crop that is indigenous for Africa. They use it for a biofuel now to try to. But strawberries or whatever we have, the evaluation it has to go through. You have to grow it for many seasons, multiple locations. Evaluate, is it invasive or does it have the potential to be invasive? And if it does, we can't release it. We have to evaluate all the different metrics, and these are not GMO crops. These are just regular crops.
So these are just selectively bred crops.
Selectively bred.
So you would establish that these seeds will grow this big, fat, juicy apple-sized strawberry. They're super juicy and delicious, and you have to do it consistently and continually and isolate it and have it down to one seed that you could give them and they could test themselves.
Well, essentially, or one plant, essentially.
One plant.
Yeah, strawberries are another good example where you can't take strawberry seeds from a strawberry and plant them and get any two plants to look alike.
That's so crazy. So you guys, how do you get those seeds then?
No, every plant comes from other plants. They make the little runners.
Right.
And so one plant, the strawberries that you get, the strawberry plants you buy, they're all clones. Just like the bananas, just like blueberries.
Oh, I see. So they're not grown with seeds. They're grown with a segment of the plant that you then replant.
That you replant. So they're vegetative.
Oh, wow. So it's like weed.
Well, yeah.
That's how I know about clones.
So I hear.
I know dudes who grow weed.
But that's the idea, is that we're able to vegetatively, as they say, propagate these things. But all of this stuff is so carefully evaluated. And with GMO, it goes through FDA to make sure you can eat it. Then it goes through EPA to make sure that it's safe for the environment. And they look at how does it affect insect populations or pollinators or whatever. And then that goes to USDA, who then tests for farm application and invasiveness on the farm. So these things are crazy tested, and all the what-ifs are really well established. Because if there was, and I always have kind of, the way I think about this is, if we do want to assume companies are money-grubbing and horrible, if something were to go wrong, it would be the end of the company and gigantic lawsuits. And so in self-preservation, let alone profit to make a decent product, these things are extensively tested.
So what do you think is, what are the top unwarranted concerns that people have over genetically modified foods?
Well, I'm glad you asked that, because I don't mean to be just, I hate when I come off as being just too excited and ambitious about the technology, because there's downsides to everything. But you have to weigh the risks versus limitations, or risks versus benefits. And some of the things that we've seen is this resistance to to herbicides. So one of the most useful GMO crops is this Roundup Ready, or really what it is glyphosate resistant. Glyphosate is the chemical. Roundup is the brand name. It's off patent now, so many companies make glyphosate. So I tend to go with glyphosate when we discuss the trait. What it allows a farmer to do is plant, say, soybeans. You plant the soybeans, and then as the soybeans start to grow and the weeds start to grow, the farmer goes over the top with an application of this stuff called glyphosate that kills the weeds, but the crop keeps growing through it. And as the crop grows, it shades out the weeds, so then the crop is the only dominant thing there. The amount of glyphosate that's applied is about about a mug worth per acre in terms of active ingredient. It's a very potent chemical that disrupts a very specific part of the plant's biochemistry. It can't make amino acids, so it can't make proteins, specific proteins. And the chemistry is well known. We understand what it affects, and you don't have that pathway. So it's a very safe chemical for humans. Lately, it's come under a lot of fire. Actually, now that people aren't attacking the gene insertion process or the traits themselves, they're going after the chemicals used. In the process of using just that chemical over and over again on land, we talked about this idea with MRSA and with mutations and with the one that happens to figure it out surviving. There are weeds that can grow through glyphosate. And when that one weed can grow through because of a mutation, now it drops its seeds, and pretty soon you got a major problem because all the rest of the competitors are gone. And these weeds take over. And now you have to come up with other methods, such as plowing or other herbicides, to get rid of them.
So this is still confusing to me. The plants are all coming from clones, but you sell people seeds. So where do the seeds come from? Okay. Why, am I dumb?
Yeah. No.
Or is this confusing?
Well, we're literally talking apples and oranges. So,
right.
So we're talking about clones. We're talking about things like strawberries, oranges,
right.
apples. When we're talking about soybeans or corn.
So if somebody buys those strawberries,
yes.
If you make this mega strawberry,
yeah.
How does someone get a seed to plant for those mega strawberries if it's all clones? Do you clone seeds? Like
no, they just take the clonal plants. So strawberries make runners. So
okay.
You have a plant that then makes a little daughter plant that comes off it.
Right.
And then you just get those daughter plants and plant those in your field.
So you don't sell them seeds, you sell them plants.
We sell them well, not me, but
right.
But our nurseries. So if University of Florida comes up with a new strawberry that's fantastic, they'll take that foundational plant, do many years of testing to make sure it's good and consistent in many different places, and then that plant will go to a nursery where it's propagated by experts who make billions of plants in a couple of years, and then they sell those plants back to our farmers.
But when a person would go to the store and they would buy seeds, like say heirloom tomato seeds, how would they make those seeds?
Yeah, those are seeds that come from heirloom tomatoes. So that comes
right.
from what you think of as single seed descent. In other words, you have a tomato that has some good qualities, then its seeds also have the similar qualities. They've been inbred so that essentially there's no genetic diversity within that fruit, that every gene, rather than having a copy from mom and a copy from dad that are different, they're all the same, or at least very narrow. And so this way you can have seeds from that same parental plant that look so that what you plant will come out to be very similar to the parent that it came from.
But this is where it gets confusing to me, because you were telling me that if someone took like one of those tomatoes and took the seeds from it and tried to grow tomato plants, they would not be similar to the initial tomato.
Well, the heirlooms probably would be because they're so well inbred.
Okay. So, but a regular tomato, a Monsanto grown regular tomato.
A hybrid tomato that came from two very distinct parents, that thing's going to be a genetic mix of many different traits, and that thing will give rise to many different progeny.
So if you got a tomato from the grocery store, one of those pale, funky tomatoes that they cut up in like Carl's Jr. and you get in your burger that just looks like sad, if you took the seeds from that, you could possibly grow different kinds of tomatoes?
Yes.
Wow.
Yeah, and so, but with things like
So
corn,
they could suck. They could be like
or
rubber.
or it could be the next the next best tomato you've ever tasted. I mean, it could be, but the chances are no, because they've been breeding out all of that stuff. Do you have tomato plants at home?
Yes, I do.
Yeah, I'll send you some seeds for one that you will
This is how it starts.
No, this is amazing. So a guy at my university named Harry Klee, they did sensory tests on hundreds of people, and they asked them, well, what do you like about a tomato? And they tested all the heirlooms on them, and they tested what heirlooms they liked and which ones they didn't. Then they took apart chemically what's in each one of those kinds of tomatoes, and they analyzed them by maybe what the consumers were tasting and the volatile components and the acid balance and the sugars, and they were able to come up with a recipe for the perfect tomato. And then they made hybrids that would fit that expectation. And they came out with 2 new tomatoes called Garden Gem and Garden Treasure, which are just going to be used in the home market. But they're tomatoes that have exceptionally high flavor, and it's one of these heirlooms bred against a University of Florida production tomato, so one of the more regular tomatoes. And the result is outstanding. It grows in Florida where everything wants to die in Florida. It's a really harsh environment. But now tomatoes are fantastic and do really well out here.
And how do they establish those seeds then? They just do enough generations of very specific tomatoes where they're confident that the seeds will yield the same type of tomato?
Well, the 2 parents are very very standard genetically. And then those 2 parents get sent to a place like, I don't know where they did these, but it was someplace like Costa Rica or something, where you can generate huge amounts of hybrids, where you have people who will hand pollinate flowers with the one pollen from the other and then generate the seeds. And so that's how hybrid seeds are made.
So they're making these seeds by hand germinating?
Or hand pollinating.
Hand pollinating, rather?
Yeah. And the result is fantastic because it's a combination of the best of the heirlooms versus the best of the production traits. And this is what's exciting for me as a scientist, is that we understand more about what the consumer wants now, and we also are understanding more about the chemistry of fruits and vegetables. So even without GMO, we can understand the genes that cause people to like tomatoes, like what are the components of a tomato or a strawberry that people just love, and then identify those compounds and breed them back in, just with traditional breeding.
What is the pollination process like? Because I watched this thing about in China, they had areas where they had decimated the bee population so badly that they had to hand pollinate a lot of their plants. And by sheer luck, they found out that hand pollination is far more effective. And if they paid people whatever the hourly wage is, it's actually more cost effective to fucking get rid of the bees, which is horrible to find out. But these people, it was way better because apparently bees are just kind of random. You know, they don't do the best job, but they don't know what the fuck they're doing. They don't know that they're carrying pollen on them. You know, they're just kind of doing it. It's not like a very specific goal for them. But when it's a specific goal and they're using like these artistic paintbrushes and brushing pollen on it, the effectiveness was like way, way better than just allowing nature to run its course.
Yeah, it may have been the case in China, and it depends on the crop too, because a lot of things are wind pollinated. So if you emasculate all of the plants that you plan to be the female parent, if you cut out all the little stamens and anthers, the male parts, you know, you take out all.
How rude.
Yeah, I know. You have to be careful when you look online how to do this.
I'm sure.
If you look up,
pictures of Bruce Jenner pop up.
You Google emasculation, so you go to pull
How
out all
rude
the.
am I?
You pull out all the.
Sorry.
Yeah, he's a hero. You pull out all the.
That's what I heard.
You pull out all the stamens, and then now this plant can only be fertilized by what comes from, you plant adjacent rows of the pollen donor. And now bees and wind and everything else will take care of that.
So these people hand pollinate these plants, then grow tomatoes specifically from those plants, and then sell those seeds or use those seeds to grow more. I mean, how many generations do they do it before they're confident that they can get a seed that if you get it, it will grow that same specific tomato that you guys engineered?
So the seed that comes from the tomato that results from that pollination, those seeds are hybrids. They have a combination of the mother's traits and the father's traits. That seed is the one that would go to you as the consumer, that now you would grow a tomato plant that would produce outstanding tomatoes.
Wow.
After that, it's a crapshoot, because genes in cells, when you're making your gametes, your male and female reproductive components, you're going through homogenizations that now you lose control of what genes are in the next generation. So that's the problem.
I think this is a mind blower for people. This one right here. It is for me, because I never really thought that the tomato that you got, like if you got an heirloom tomato, it wouldn't necessarily grow heirloom tomatoes from its seeds, because that's just not the way it works. I mean, I would have always assumed that you would be able to get it that way, but you telling me that what you guys had specifically done, that you had to hand pollinate in order to ensure that that would create those certain types of tomatoes, that's fucking nuts.
It's the way it goes now when you make hybrids. But there's so much more cool stuff in plant genetics that we can do because of this kind of thing.
It's very cool, but it's disturbing, again, to dummies like me, because then all it comes up like, whoa, people are in charge of the process of creating this very specific form of life. I mean, that's really what that tomato is. It's a living thing. It's a very specific type of vegetable, or it's fruit, right, technically?
Yeah, it's technically a fruit.
A fruit life.
Botanically.
That human beings are, you guys are the mothers of these special tomatoes. I mean, essentially, it needs people.
Well, sure. Ask me about seedless watermelons. I mean,
what the fuck is that about?
you're looking,
how does that work?
I mean,
what came first, the chicken or the egg? It doesn't make sense.
There's a case where you're using chemicals to change the number of chromosomes in a cell. So now this plant has twice as many chromosomes. So now when you cross it against one that has the normal amount of chromosomes, the result, so you would have, let's say, two times the chromosomes. In the next generation, you would cross it with something that has the normal set. The resulting ones have this weird intermediate set that can't be fertile.
Okay, I'm going to play the part of the dumb hippie. Man, it just doesn't feel right with you just like fucking with nature and not knowing the results. I mean, the world has like a biological system, and you're just tampering with it without totally understanding ramifications of what you're going to do. And there's all sorts of cancer and autism that exists today, and a lot of it is because of scientists' ignorance. They think that they're so smart. You're smarter than nature. You're going to play God with tomatoes. I just think that's fucked, man.
Yeah, so
That's my rule. It was pretty good, right?
Well, I've met that guy over and over again.
What do you say to that guy?
Well, the thing that breaks my heart is that I like that guy.
I like
pretty
that
much
guy too.
I mean,
unfortunately,
you know, he's not up in my face about anything else. He's doing his thing. We listen to the same music, probably. We're both into worrying about the environment. You know, we're on the same page with 90%. It's just that he worries about this in this one aspect of food production that humans have always changed food, and we've just now learned how to do it with precision. And so this is where he's got to kind of, have a little, come to Jesus moment here and say, this is science working for him.
I think, again, it goes to that this is a very, very complex issue that doesn't have a lot of black and white in it. It has many, many shades of gray. And like all things, there's pros and cons to the application of it, especially really complicated things, like anything involving biology. There's pros and cons. There's variables that we can't control. With our consumption of food, with the level of pollution that we allow in the environment. I mean, we have like dedicated numbers or just prescribed numbers that you shouldn't go over. Like if we go over this, well, we fucked up that area. We got to get out of there. I mean, there's spots that human beings can't go to right now because of chemical dumps or because of nuclear reactor accidents. There's spots that we've totally ruined. And this is just a part, but we also have fucking power everywhere.
Right.
We also have electricity. Yeah, there's some bad shit has happened. But look at all the good shit. There's 7 billion people on the planet. There's never been numbers like that. The only reason why there's numbers like that is because 100,000 of them are smart as shit. And those really small, maybe a million, might be a million out of 7 billion, right? That have been responsible for putting together this amazing society. It's not me. But those people that have, yeah, there's been some mistakes along the way. But I think without that innovation and that thirst for improvement that people seem to we just have, like inherently, like a guy like you, when you're talking about the application of these technologies and the application of this science and this work, you get all jazzed up. I mean, you almost started crying when you were talking about these people that you had met that were emaciated.
Yep.
You have a deep connection to this.
Yes.
And then, so you're fucking important as shit, dude.
Well,
you're more important than Jay-Z. I just said it.
I'll take that.
Said it.
But you know who is responsible for 1 million of those 7 billion? Do you know a name Norman Borlaug?
No, you see the guy who created golden rice?
No, Norman Borlaug, he did more than that. Norman Borlaug was a wonderful, simple came from a farm background, became a scientist, and studied ways that he could try to solve problems on the face of the earth for the hungry, and especially in India and Mexico. And his idea was to take the kind of plants that may never be able to mix naturally and make some crosses, dwarfing varieties, so plants that were lower to the ground that would have fewer problems. And he made these crosses that really would go to feed a billion people. Wow. And and scientists like me, I look at him and he is the ultimate hero to me. He's a guy who should be a household name here. I stand on the shoulders of a giant, and he passed away in 2009. And those of us who've heard about him, who've read about him, who had a chance to see him speak, it changes us, because it was his compassion to take care of the needy that drove him. It wasn't about making a dollar. It wasn't about Monsanto. It was about being the guy that when he came to the village, everybody said, let's take him out to our best restaurant because here's a guy we like. He was a guy who insisted, if you visited his campus, to carry your bags to your car, despite the fact that he was a Nobel laureate. That's the kind of role models that we have in science, and this is the kind of role model that other people have to be aware of, that for every Norman Borlaug, it's going to take a few million evil scientists. We have to understand that, and he made crosses that were amazingly diverse, and that brought plants together that couldn't survive, that would never happen in the wild, and fed people because of it.
See, he's the good scientist. You're the good scientist in the movie, too. So when the evil scientists come, they try to take over the world, we need you to be the ones that sound the alarm. Like in every good movie, like The Day Before Tomorrow, whatever it is, Day After Tomorrow, right? You need the good scientist that figures out that shit's going wrong.
Well, yeah, and they're on surveillance. I mean, it's not just me. There's thousands of me.
Much more on surveillance now than ever before, right?
Before, not just because we're aware of it, but because of the tools we have. And it would be, to me, it would be a career maker to find something wrong with a Monsanto product and report it in the best journals.
So wouldn't you worry, though, like a good Russell Crowe movie, that they would come after you?
Not at all.
You wouldn't worry?
I'd say
You're fearless?
I would say bring it on.
Bring it?
No, totally.
Wow.
I am fearless. I love talking to the anti-GMO crowds. I mean, I go into, and I'm the one they call because they know I'm reasonable. But I go into places and people will get in my face and yell at me. I'll have people come up and scream at my face about how my company has given their kid cancer. I mean, I get some heavy shit, and it happens often. But the idea is to get into those rooms and get into those spaces, just like we're doing here, and have a conversation and introduce people to technology and get them to de-Monsantoize this. Talk about ways that we can make it work to make plant products that would require fewer pesticides, like the BT has.
How many people have come up to you and yelled at you that you gave one of their loved ones cancer?
Two.
Two?
Yeah, one of them was in Hawaii. It was a woman, beautiful woman from Brazil, I think, originally, who had a child who had cancer, and she said, "Here's what your company did to my child." And
what company did she think you were representing?
I assume the Big M or one of the big companies. And the reason I was there was because I was invited by the companies to come to the island to talk to people as a neutral party because they were having a lot of conflicts.
You were invited by Monsanto?
Well, no, I was invited by the Hawaii Crop Improvement Association, which is like a group of a whole bunch of companies.
Okay.
And they said, they're not listening to us. They don't care what we think. What about an independent scientist? And when I came there, I made it my business to not hang around with the Syngentas, Monsantos, Dows. I didn't want to talk to the other scientists. I wanted to talk to the farmers, and I wanted to talk to the people who were afraid and the people who had concerns, because I could help them understand. And that was what my goal was, to help them, to talk to them. And anyone who was there, even people who are adamantly anti-GMO, I think many of them would agree that I was very peaceful and very quick to engage them. That when I saw people in the audience at farmer forums where I was speaking, I'd see them shaking their heads and going, "No way, no way." The minute I was done and the applause was over and the questions were answered, I chased them out into the parking lot and said, "I need to talk to you." Because this is where this conversation needs to be. It needs to be one-on-one over a pizza and a cup of coffee. It can't be It can't be on the internet where there's noise from, documentary sellers and people with agendas.
Well, what about face to face when this woman is yelling at you that you're responsible for her child being ill? Like, what do you say to someone like that?
I said, I'm really sorry for what's happened, and I would love to help you solve this problem or not let it happen to somebody else. And I said, if there is something here on the island that caused this, we need to understand it, and we need to get to the bottom of it. But as a scientist, it's not GMO crops. I mean, there's nothing that I can think of that's plausible or no evidence that I know of that would point that way. And then I told her about the state USDA, the person. I gave her the name of the state USDA person. I said, here's the person you call and tell them where you live and have them come talk to you about it and analyze the patterns. And that's the kind of advice.
This was from another country?
No.
This was in Brazil?
This was in Hawaii.
She was from Brazil?
I think so.
So was she living in Hawaii when this happened?
Yes.
So there's something that they had dumped in Hawaii. It was the United States.
Yeah, that's the allegation. A lot of the people on
I got confused. I thought she flew from Brazil to talk to you.
She was. I had a conversation with her, and I think I got that information from her at the time because she had a very strong accent.
Okay.
But there is a lot of very strong anti-GMO sentiment on the island of Kauai and in Hawaii, actually throughout the state.
Well, I mean, how could it not be?
Sure.
If you look at what they have paradise.
Yes.
And they're like, what are you going to do? You going to fuck with paradise? Dude, we're okay over here.
Well,
get out of here with your fucking funky bananas.
But here's the deal: is that our farmers rely on this because Hawaii, you can grow 3 seasons of corn a year. So you can use it. What they use it for is seed production. Mm-hmm. You generate the seed that's planted in Iowa on Kauai.
Wow, that's amazing.
Yeah, and you can do 3 seasons a year
because of the amazing weather,
rather than 2 on the mainland or 1. And so you're able to sell the farmer cheaper products or keep the costs under control of a product. Plus, the environment's perfect. It's dry. The seed is of good quality. So they do a lot of seed raising on Hawaii, and very strong anti-sentiment. And I understand that. It is a beautiful place, but it also employs lots of people on the islands.
I think one of the things that you discussed and we talked about earlier that I thought was really fascinating was this idea that planting crops isn't really natural. Because I passed through Alberta this past weekend, and I was driving through these enormous agricultural areas, and I was thinking to myself, like, wow, this is really crazy, like, that we do this. We just take over these giant swaths of land and fill it with shit we can eat, and then we run over it with giant machines, collecting it, and then bundle it up and sell it throughout the world. Like, it's a really bizarre practice, and it is absolutely unnatural.
Absolutely. And if you look at where the crops came from that we grow, I mean, corn doesn't belong in North America. I mean, it came from southern Mexico. It wasn't in the United States and Canada anyway. If you look at a map, and I'll show you one maybe later, or if you look up crop domestication or centers of origin of major food crops, you see that there are maps in Google Images that show that U.S., you have sunflowers, maybe some progenitors to strawberry and blueberry, and maybe some kind of brassicas that might be like canola. But for the most part, there's nothing that comes from here. No tomatoes are from South America, potatoes, peanuts, citrus is from Southeast Asia, apples are from Kazakhstan. All of our cabbage, kale, broccoli, cauliflower, all that's from the Middle East and Mediterranean areas. So nothing's from here.
Dude, kale is totally natural. Fuck off.
Yeah, see, this is a pretty good example here. But that talks about, some of our major crops. Certainly, there's sorghum.
Yams and potatoes came from South America. Peanuts, South America. Wow. African rice. This is nuts.
There's lots of good examples.
Squash.
Yeah, squash came from it's also from Mexico, along with beans, close to where maize was domesticated.
So there's some kinds of squash that were native to North America, but not many. Look, what is that? Pepo squash?
Pepo squash. So pepo's like any kind of cucurbits like pumpkins and like the squashes, cricknick squashes like we have.
It's weird when you look for yams.
I know.
Find yams on some creepy little island in the middle of nowhere.
But this
look at yams. Yeah, what is that?
They love that stuff. It's
what
over in Indonesia
that?
Or something there.
That's where yams come from.
But they take. But this is all of the movement from those crops was human mediated. I mean, humans drag that stuff around.
Quinoa, man.
And so all of our domestication that we've done has been human facilitated, and the genetics change accordingly.
Oh, so there's some yams that are also from South America, it seems.
Well,
Or is that Central? That's South America,
yeah,
right?
that's South America there. But this is the beauty of this. If you look at strawberry, it's a great story because strawberry grows naturally on the forest floors of North America and also from Chile. But the two are two different species.
So there's two different kinds of yams then.
And it's probably two different species.
Yeah, it says it is. It's got two different names.
Two different yam names.
That always weirds me out too. Why does it have two fucking names? Like it's got its rapper name.
It's
you know, it's Coolio. Dude, your name's not Coolio. What's your fucking name? You know, that guy. What's his name? 2 Chainz, bro. That's not your name. You can't go on CNN and debate Nancy Grace about pot. You don't have a real name.
Your name's
you need
Snoopy.
a goddamn name. Yeah, but.
So strawberries is a cool story.
If you look at this though, like yams, why do we have to? What's this? What's your fucking name, dude? It's D. What is it? How does this?
I don't even know what the genus is on that, but it's
G. trifida. Trifida.
It's D. trifida versus D. alata, and they're just reproductively isolated. And
but
so
they are essentially the same thing. Are they interchangeable?
They're probably two species from the same genus, so they're related, but they're reproductively isolated.
Why do they have rapper names?
Because they can't cross with each other, unlike rappers. They can't cross with each other.
Well, why don't they have their name then? Why do we have to dumb it down and just call it yam and yam? Why isn't one D. triflecta and one D. alerta?
Well, that's what it is. It's yam 1 and yam 2.
Right, but nobody thinks about it that way. You go to a supermarket, it doesn't say that.
No, well, because the ones you get in the supermarket are probably just one kind. This other thing is probably something
some freaky yam.
Yeah, it doesn't work in production.
But it is ultimately very fascinating to look at this map and think about what it must have been like, of course, to be people that were traveling all over the world looking for plants and looking for spices.
Yeah.
I mean, that was like a big part of the whole trade where they would get on boats and travel to foreign lands. They were trying to find plants and spices and shit.
Oh, yeah. Well, let me tell you, the strawberry story is so cool. That they grow in the forest floors of North America, like eastern seaboard, and people were dragging them back to Europe on colony ships. And 1500s, there's lots of them going back, and you can find accounts in the literature. And then in 1714, there was a spy who was going to South America, a French spy, who was going to Chile to look at Spanish fortifications, and he found a kind of strawberry that was being grown by indigenous peoples, and he brought this thing back to Europe. And he wasn't, and unfortunately, these flowers were only male. There was you had a problem where these plants couldn't self-fertilize. So these plants from South America and these plants from North America made their way to the botanical garden in Versailles, where a teenager essentially started to identify crosses between these two species that came in different places because of spies and colonists, and there the pollen got together to make our modern day strawberry.
Whoa.
It's got 4 complete sets of chromosomes, so it's a genetic mess, but it's something that we all love and enjoy, and my lab helped in sequencing the genome a few years ago. It's this is how cool that plant domestication is. There's so many stories. Every one of these plants has a really cool articulate or reticulate story about the way it came to be on our plate.
I just think plants are absolutely fascinating. Like I said, I know guys who grow marijuana and they use clones, and I had no idea what that even meant until I went to this guy's green room, and I was like, wait a minute, you take a piece of this plant, you grow more plants. So he had gotten arrested. He was one of the first guys to get arrested for the medical weed, and Todd McCormick. And his setup, the way they had charged him for individual plants, they had said his clones were individual plants. But if they were like in bulk, if there was all on one plant, it would be legal, or it would be less illegal. Like to take that plant and clone it, then it becomes a unique object in and unto itself, because that could be used to grow more illicit drugs.
Right, it's an independent entity.
Yeah, I always thought it was seeds.
No, it's funny because so my main research, we didn't even talk about that stuff, but I work with identifying genes associated with flavors in strawberries and things like this using genomics tools, but I also do a lot with light. And so I do a lot with LED and a lot with how you are able to change plant traits using light, so make them taste better or change the way they grow.
Wow.
And I've been getting emails. I was kind of one of the first folks in this, well, I shouldn't say that. I was in the space early back in the late 90s. And I've been getting emails from like, stoner18@AOL.com for years. And people asking about how do you grow a plant that you would want to grow under what color lights. Because there's so much of that production which has been brought into controlled environments. I never was able to answer the questions very well because we're forbidden to work on such products, at our university anyway. Using light to control those aspects of plant growth and development is something they're really interested in.
That's fascinating. Is there any benefit to growing plants in sunlight as opposed to artificial light?
Well, this is actually a really big part of my program. Is I do what's called plant whispering.
Wait a minute. You play that music? Do you play your punk rock next to them and they grow aggressive?
That's right.
I'm sorry. What's
fight the power?
What is plant whispering?
So plant whispering is basically where we use light so if you think about a plant, plants have 12 different light sensors at least that listen to different parts of the spectrum. So plants can see red, blue, green, even the red light that's off the end of the spectrum that we can't see, and they can see UV. And so when we give different pulses or different treatments at different times of the day, we can change the way a plant grows, what metabolites it accumulates, maybe the flavors. We can make cilantro taste absolutely horrible. If you like it, we can make it taste so cilantro-y, it's difficult to eat. But we can change plant flavors, we can change their colors, we can change many of their attributes. And now we're trying to understand how we can give light treatments to plant materials, like harvest strawberries, treat them with light before they go into the supply chain, before they go to the store and through all the refrigeration, and have them change their gene expression patterns so they come out the other end better and last longer in your refrigerator or last longer in your countertop. So our idea is to essentially change the gene expression in fruits and vegetables using the language of light to dictate how they decay. And my feeling is that we've got, you say 7 billion now, we got 10 billion, 3 more billion coming. We have to use the same space. Right now, if you buy a tomato at the store, or let's say you pick a tomato off the plant in Florida, the odds of that tomato being eaten by a person are 1 in 2. 50% of our food is wasted. And because
it goes bad?
It either goes bad or it spoils, and in the developing world, it either spoils or gets infestation. And one place where we can really solve the problem or address the problem of the 10 billion is in post-harvest technology, what they call post-harvest. And this isn't GMO stuff. This is the other thing I do. We're really dedicated to the idea of getting more food for people by having more food last longer. And using these kind of light treatments and other kinds of mild chemical treatments or washes or whatever, this is one part of it. Make what we have last longer.
So would this involve artificially growing these plants under artificial lights, or would it involve like growing the seeds from the plants grown from artificial light? I mean, how would it be done? I
think if you'll see a lot of this online these days, that there's a lot of companies that are starting in abandoned warehouses and places where they use LED lights to do what's called vertical gardening, where they grow plants in city centers where you don't have the transportation costs and the carbon footprint. So you can bring plants to market cheaper and maybe even higher quality products. So what I think about it, and this is where we think about this versus GMO. GMO, we change one gene. We know exactly what it is. We understand it. EMO, or environmental modification of plants, which is what I like to think of plant whispering, we're changing lots of genes in ways we don't necessarily understand, but we enjoy the outcomes. And people don't really care.
But that's what freaks people out, because people know that like light is not artificial light. It's not necessarily good for human beings. Like if you live in a room filled with fluorescent light, you'll get vitamin D deficiencies, right?
Yes.
Is that similar to the light that we use for plants? And if so, is there a concern that there's a similar negative reaction somehow or another in those plants where they wouldn't be as healthy as they would be in natural sunlight?
Oh, sure. That you can have cases where plants, since your whole metabolism is driven by light, the whole photosynthesis, that if you have problems with your light sensing, that's why you have 13 different light sensors that control your growth and development, because you're paying attention to every aspect of that ambient environment. and making very good let's say, predictions or conclusions based upon the information you get from the spectrum. And that's where we've been actually thinking, and where we've applied the idea of manipulating the spectrum to change the way the plant grows. Ultimately, anything that isn't beneficial, we're not interested in. We want to grow better food that's more nutritious and lasts longer so that we're able to grow things more sustainably.
Are these lights normal lights, or are these lights like some very specific growing type lights that they give off a very specific spectrum that's not like normal LED or fluorescent lights?
Now, there's specific combinations of LEDs that are computationally controlled.
So it's controlled at a certain, what would you say, amperage? Like what would you say as far as wattage?
Well,
like what is the light? What's that meter?
Yeah, you kind of got it. It's they're all at different. In the light business, we call it fluence rate, the number of photons that are produced per per square meter. The idea is that some of the photons we produce that give plants information you can't see. So you can't really call it, intensity. The stuff that's in UV and off the end of the red part of the spectrum, it has information for plants that's really potent, but it's not information that you can see. But the plant if you put a plant under far red light, the stuff off the end of the red part of the rainbow, the plant goes berserk. It starts growing really lanky and long. It accumulates specific pigments.
Whoa.
Yeah, I mean, it allows you to manipulate the plant size and body of the plant.
And does it have any consequence on the actual product that the plant produces that's consumed by humans, whether it's a tomato or an avocado or whatever? Is there anything about this light that changes the actual food that you eat?
Oh, sure. Yeah. And what we use it for, and we've done most of our experiments on sprouts, like kale sprouts. We can make kale sprouts change the level of glucosinolates, which are the anti-cancer compounds. We can increase that stuff just by using light. We can change.
That'll probably give you cancer. Wouldn't that be ironic?
Well, yeah. Well, you also can change the like the attractive colors. Make things that are purple or green. I can make there's a kind of lettuce I can grow under 8 different light treatments that gives you essentially 8 different kinds of lettuce leaves.
That taste different, look different.
Taste different, look different.
Wow. And is it discernible to the naked eye? Like, would I be able to walk in there and know which one is giving off which thing, or is it just
No, it's a recipe of light that gives us a given output.
But you know what I'm saying? Like if you had 4 different rooms, you were growing 4 different kinds of lettuce, would I be able to walk in those rooms and discern that there's any difference in the light of each individual room?
Oh, sure. Yeah.
Oh, you would?
Like crazy, yeah.
Oh, okay.
It's there's a lot of this stuff you can even find online with like if you look at like LED and plant growth, you'd see all kinds of different ways that people do this. The problem is that most places stick plants under a purple light or under a pink light and they get some effect. What we don't want to just grow a plant, we want to tell it how to grow. And I think the future of growing plants in controlled environments will be deeply rooted in this ability to control how they grow.
The key word is control, man. I know what you're trying to do. You're trying to make lettuce that fucks with my head. I know what you're doing, dude, with your light theory. It just seems like that's the thing that people would be worried the most, is that there would be some sort of nutritional deficiency in something that's grown with artificial light, that growing something in the sunlight is somehow or another better for you. Does that make any sense at all, or is that just total nonsense?
Well, it could be true, but that's the idea.
Could be true, but it might not be.
Well, what we're looking for is, again, we're not looking for like the deleterious result. What we're trying to do is, what is the combination of variables that we can control to make something that's better for people? Mm-hmm. That's what I'm dedicated to. That's where I want to go.
So it seems to me that there's just a giant positive aspect to this about keeping food for longer, feeding more people, giving people nutrition in areas where it's unavailable. It seems to me there's a massive, massive positive benefit of it. What can we do to mitigate or prevent any negative aspects of it? You know, the negative aspects of it being that somehow or another it could harm people. Somehow or another the corporations behind it would act in a greedy way that would be detrimental to the area where the crops are grown or whatever. What can be done?
Yeah, I think, and I guess I'm kind of tooting our own horn here by saying we need to support public science. We've got this group of people, like in the land-grant university system. This was a brilliant idea that came out of the Morrill Act back in the 1860s, where they established a university in every state that's job was to take care of the public need, where you train the students, you help the farmers, you do the research that puts you at the cutting edge to help the farmers and train the students. And that's a model that's still here today. University of California, Davis is the best in the world at this. And they're amazing at the things that happen there. The problem is that as a nation, we've been less excited to fund science. Right now, if I write a proposal to the USDA or National Science Foundation, the odds of it getting funded are between 5 and 10%. And if you think that they have these competitions once a year, you may go 10 years without getting a research award. A lot of labs are closing up. We're not training students like we used to. And it's because of there hasn't been this public demand to fund science. And I think a lot of that comes from they go, well, scientists there are just in the pocket of Monsanto anyway. Why do we care? When that's totally not true. The best defense against an evil empire is your public scientist. And we're struggling for tools right now.
How does one get hired? Like if one is going to college and you're graduating, you're getting your master's and whenever you're getting it in, and you get recruited by a company like Monsanto, does that happen? Or do you go to them and look to get a job? Like how does a scientist become a good scientist like yourself or an evil scientist? Like even the most evil, we would think the guy who created the atomic bomb, but Oppenheimer wasn't evil at all. And he was actually really disturbed by the whole event, the thing that he had created. But he was a part of this scientific process that ultimately seemed necessary at the time, being the first person to come up with this bomb. So how does one get hired? But that's very distracting. But how does one get hired, like out of college, and how many scientists does like a company like Monsanto employ?
Well, Monsanto is, I think, 24,000 employees. But
how many of them are scientists?
I don't know. Probably a good chunk.
Everybody else just takes out the garbage.
But to be honest, I do know lots of people who work there, and lots of our former students from our program have gone there because they're hiring. Universities aren't; they are. And but just to give you an idea, you go through at least 4 years of undergraduate. You require sometimes a master's degree, sometimes a PhD that takes you 4 to 7 years. Then you're talking about postdoc time where you're looking at between 1 and 6 years. So you're 35, 36, 37 years old before you ever even get a job. And
that is insane.
And that's if you, in academia where I work, it's so rare to get a job. It's really tough getting academic positions. But the companies are happy to take these people, especially people with good backgrounds in plant breeding. Because Monsanto, at the end of the day, they're not a GMO company. They're not a chemical company anymore. They're a plant genetic improvement company. And they're working on breeding plants so that then you can add that gene to the elite background. There's only so much you can do with a GMO transgene. The rest of that has to be done by breeding. And lots of plant breeders, like people come through my lab. The 2 plant breeders through my lab, one of them got snapped up by one company, another one got snapped up by another. Right out of the PhD, each one of them into a 6-figure plus salary, plus all kinds of benefits.
Do you ever think about going over to the dark side?
I've been recruited many times. And
the force is with you?
But it's not my mission, I like
how you're staying with my Star Wars terminology.
I could, my Yoda said, "Stay in university, you must." I was my whole thing is I think I like being in the public sector because I don't like to have secrets. I don't like to have proprietary information that I can't share.
Right.
My whole thing is, and I've been this way my entire career. When I got the first little bit of strawberry sequence information. With a $1,800 grant that I got from the Florida Strawberry Association. We got the first little bit of strawberry information. We gave it away because the idea was to spark more research and more discovery. We could have sat on it and used it just for our lab. But
so you guys are like the Elon Musks of strawberries.
That's the idea. You make it, you distribute it, you work faster. Open access, open source, as fast as you can. And but this is the main thing with the companies. For me, it's about that role. And I like to work synergistically with the companies. I have good relationships with Monsanto employees, Dow employees, you name any company, because we have the same clients. My job is to make sure farmers know how to use Monsanto products, Monsanto seeds. So I need to know what the company's up to.
Well, it seems so crazy that it's so easy to get hired by a giant corporation and difficult to get hired by public universities. It seems, but it's totally logical, obviously. There's going to be way more people that are pursuing a degree in science than there are openings. So is that difficult to encourage young people to get into science because of that when they look at job prospects? Is that a real issue?
I think it is. And really, one of the funny ironies here is that back in 1999, Monsanto actually gave my university some money towards a position. So they said, you guys are short on faculty here, let's start one there. And they hired a guy who's never done anything for Monsanto ever since, but has done some beautiful science for the public good. And we're always criticized about that. People say to me, well, you've got that position in your department. That must mean everything you say has to go through. It's like totally not that. You know, I'm grateful that companies do anything for us, if anything. You know, like if anybody wanted to build a new building on our campus, I wouldn't say no. But that doesn't mean they're going to get any favors.
So when you, okay, if you are involved in any sort of a project or any sort of a scientific analysis of something, are you required to release the results to your superiors before you go public with them? Or is there no obligation whatsoever? You could just tell anybody at any time what you've discovered?
Yeah, no obligation.
That's beautiful.
I research what I research, and what I can raise money for from USDA, NSF, NIH, wherever I can get money from public sources. Even strawberry industry, there's some strawberry industry sources that give me some funds. But that no one goes, there's no filter. And sometimes it's good to have people read just to make sure you don't say something dumb. But there's nobody who ever says, no, you can't publish this. And if they did, I'd publish it anyway. Because this is about science and the truth. It's not about making anybody happy.
Well, that's the big conspiracy. It is always the big conspiracy in almost anything that's in the public eye. When people are allowed to scrutinize something from the outside and guess what the process is. I didn't know. That's why I had to ask you. Yeah. You could have easily just said to me, I mean, as far as I knew, you could have easily just said, well, everything that I do has to go through a board and they have to vote on whether, I don't know. I have no idea. Yeah. And most people are in that same place.
Yes.
Like, I've been accused of, with different jobs that I've had, different shows, and even working for the UFC, of someone telling me what I can and can't say. And that's just not the case. But what I do is super simple. I'm just talking about fights. Like, if someone told me not to talk about something, it would be of, like, not much significance. Okay? It's just about a martial arts event. What you're talking about is these discoveries that could potentially impact untold thousands of people in a very beneficial or in a very negative way. Mm-hmm. So everybody's got that worry. There are people, but again, it's be on the outside. That's what it is. I
totally get that, because and especially when we're in a country where we're all pretty comfortable and we all have plenty of food and we have a few bucks in our wallet to do stuff, that we do tend to focus on the worries and on the what ifs.
Exactly.
Because everything's fine. We're afraid of something upsetting the apple cart. But I can tell you as a scientist that if I were to find something, like just through some process, through some experiment, find something wrong with a Monsanto product or a Dow product or whatever, I don't like to just pick on the big M. I find something wrong with a product in agriculture that would shift the paradigm, that would change it from something safe and used everywhere to something that we better have some alarming care with. That would be something that, when I publish that, it would be on the best journal, it would be in Science or Nature, and then it would be replicated by other labs right away as soon as it was published. I would get huge notoriety. I'd get grants forever. I wouldn't be in that 5% anymore. I'd be getting leading grants because I was the guy who broke the rules. I was the one who broke the paradigm, and probably get a Nobel Prize out of it.
So you don't think that there would be any negative repercussions before it was clearly established that you were correct? I mean, if you're, like we were talking about before, if it's involving a corporation that's profiting in the billion-dollar range, they're making insane amounts of money, and you have some information that would put a monkey wrench into the gears of this incredible money-making venture, you don't think there'd be negative repercussions?
No, I'll tell you exactly what would happen, and I'm sure this is what would happen. The first people I would let know would be the company that makes it. Get your product off the market. Here's what I got.
And then your brakes would fail on your car, and arsenic would show up in your tuna fish.
Well, but see, that's the kind of stuff that you
in the movies.
And once again, going back, Dr. Evil, But it's. I think that a company who would make them, if someone were to reveal a mistake, they would be the first ones who would want to know, and because they would have.
That's disproven though by history.
And in ancient, and when you go back and you talk about things like
how about GM?
Right.
How about this whole fucking ignition thing? We talked about it earlier today. They knew, and they kept their fucking mouth shut.
No, it's a good point. And it ties in with my kind of naive idealism sometimes that I think everybody's going to do the right time. I know,
punk rock hippie.
I know, but at the same time, but the other side of the coin is that if I was the guy who discovered the ignition issue, and I was an investigative reporter, and I was able to put together 7 or 8 cases of this and would tie it to the ignition, and did a study that analyzed the mechanism of failure. And I went to or GM and said, this is a problem, this doesn't work, and they refused to respond. I'd put this in the newspapers that I would look at it. I'd put a blog that everybody would see. I'd come here and talk to you about it. And I would blow the lid off of that, and I'd get a Pulitzer Prize.
And you'd write an awesome book, and the book would get published, and you'd make gazillions.
Well, hopefully. And so, but this is how it should work, is that we got to have, but those are scientific processes that go through a series of steps to develop evidence that's analyzed to come to a conclusion. And then we can shape policy based on that. And that's where I get excited about what we can do with science.
Well, there's reasons that people are worried, though, about information leaking out that could harm companies. I mean, there's reasons why people shield their identity when they're leaking certain information, because they get caught, and then those companies get really pissed off, and even if it's just lawsuits. I mean, any company like Monsanto could cripple any normal person just with lawsuits. You would never be able to keep up. They would just smash you with lawsuits. When you are in charge of this kind of information, obviously we're not talking about the conspiratorial stuff. We're talking about like the nutritional things, like the bananas that you're passionate about with the vitamin A in them. What is that feeling like when you're being ignored, or you're being either it's a conspiracy by these companies that they don't want, or these people that they don't want to open up the door for genetically modified foods, or it's ignorance to the science involved with these people and their massive amounts of blindness? What does it feel like to be the guy who knows? Because that's got to be a crazy place to be the scientist who actually understands the mechanisms involved in the creation of these very organic products that were manipulated by human beings, and how they could benefit human beings. And nobody understands you. They're all thinking you're fucking crazy, or you're a shill, or what does that feel like? It's
horrible. But this is why I appreciate you so much in letting me do this today, and why people like Cara Santa Maria, who has been so helpful in talking about the GMO issue. It is an anytime we can talk about this and get people to understand, where I'm coming from, that there's trust here. Joe, every night I answer 30 minutes to an hour of emails from the concerned public who ask questions to me about this.
I was watching your Twitter today, your feed between yesterday when I announced that you were going to be on, and today. Dude, you've been nonstop. I mean, you're tireless with this stuff. You have a real incredible passion for this.
I've done Reddits where I would say I'll come on with an Ask Me Anything for 2 hours, and I'll stay on for 6. I'll stay on for 8. I'll answer 1,000 questions. Every one of them hand done. I'm not cutting and pasting. I'm addressing that person's concern, because this is how we're going to change it. It comes from talking to people who have concerns and people who are worried, and help them understand the science. Because if they get this, then they're less likely to worry about the real problems, and that's why we worry about the artificial problems, and start focusing on the real problems.
And how important is it to fund more public science and to try in some way to make more people attracted to what you're doing, as opposed to going over to these universities? Because if people really are concerned, probably that's the best way to deal with it. The best way to deal with science is to fund science.
Yes. 100%. It's to fund science and make sure that public scientists have the tools they need to maintain this.
They don't get corrupted. The idea of being corrupted seems so tempting.
Well, but we do have to be careful, because companies can fund individual laboratories or programs or universities, and it doesn't necessarily mean corruption.
Of course, they can be very beneficial.
And they can help us a lot. And I would love to have Monsanto hand me a check for $5 million and say, have at it, do what you want.
I bet it's on the way right now.
I've been waiting an awfully long time, Joe. People have been saying it for 20 years now that I should be getting.
They're ready. They're ready. They're writing that check right now. They just licked the pen like in a movie.
The other really cool thing, though, that we can do is I think get kids fired up about science. And with kids, I find that this idea of genetic engineering isn't a big deal to them, that they kind of get it, and it's kind of like molecular Legos. They kind of get the idea that you can take something out of one thing and move it to another. You can move traits. Kids have this kind of modular understanding of the world anyway, that they're comfortable with bits and pieces coming together in different ways to make different products. And when we talk, I spend about maybe 2 or 3 mornings a month with 3rd to 5th graders, 7th graders, mostly 3rd and 5th. They're a lot of fun. 3rd graders are the best. And we talk about how to solve the citrus problem. And I told
third graders.
Yeah.
How many of them say magic?
Well, you know what? They say even crazier stuff, which is
Like
great.
what?
Well,
Alien stardust.
Well, I'll give you an example. Like I show them, the way I teach this is I show them what the problem is, that there's an insect that moves a bacterium to a tree that gets sick and it dies from bad nutrition. And I'll say, and I'll show them all that. And I'll say, okay, stop. Now you guys are the scientists. Give me a solution. And the hands go up. And one of them will say, give it better nutrition. And then another one will say, maybe you could cross it with a tree that doesn't get sick. And they get that. You know, they've got sex figured out well by then. Then you talk about, then one of them will say, the funny one was, build them in a dome under the sea where the bug can't get to them, you know. And the challenge for me...
that one's awesome.
Yeah, well, I told the teacher to keep an eye on that.
Drug test that kid.
Yeah, but the cool part about that, though, is that he's right. If you could isolate the things from the insect. And so my challenge as a teacher in that scenario, when I'm interrogating their interest in science, is to somehow never tell one of them that they're crazy. Right. That I have to take whatever answer they give me and somehow loop it back to, well, here's how you're right and how it just might work.
Oh, I see. So you're 100% attempting encouragement of curiosity.
I am getting kids to creatively solve a problem. And
a dome under the ocean.
A dome under the ocean. And you know what? And when you do that, then I do that, then I go forward into the slides about how we are solving the problem. I can say, you know, Dave, you raised your hand and said use better nutrition. Look at how they're using nutrients to make it better. Someone else said you control the insect. Here's 5 ways they're controlling the insect. It shows these kids, they validate that their suspicions about science and that their creative juices that solve the problem were correct.
So how do you address the kid with the dome under the ocean? Because there's so many fucking problems with that idea. Well, it seems cool, but there's a whole photosynthesis issue. There's oxygen. You'd run out of air.
Yeah, there's crayons and paint and things, and the world needs artists, and I kind of can steer them that direction.
So what do you...
I'm very...
He's like Stephen King, like the Dome book that he wrote. The kid made a whole fucking ocean garden that way.
There's ways to tie them back in, but I think the whole idea is that they're so used to their teacher saying wrong, that here's a case where I set up a situation around a real problem that's in their state, maybe in their yard, that allows them to actually exercise their science muscles as little kids. And I think that's a big way we change this. Yeah,
that is a really important point when it comes to human beings, little children, is figuring out a way to not make their curiosity a negative. You know, don't scold them for having a ridiculous imagination. You know, express the issue with it or how it could be right and why it's probably wrong. Yeah. You know, and you got to figure out a way to reward them for taking that chance to come up with this dome under the ocean. Because who knows, that kid might have 3 of those that suck, but one of those that everybody goes, hey, wait a minute.
Well, that's the paradigm shift.
Goddamn point, yeah.
That's what we want. And there's a great video, a great TED Talk by someone named Alison Gopnik. And Alison, I forget where she's at, maybe Berkeley. She is a scientist who studies the way kids think. And she shows that children, when they're born and through the next few months, are actually the smartest they've ever going to be in terms of their ability to test hypotheses and synthesize information. And she shows the way kids do this. And so... you know, maybe I don't want to be like an indictment of the way we train people, but there is a certain amount of curiosity and exploration that we tend to break out of kids. And I think as an educator, as someone who is really committed to education, that getting to kids is the most important way to get science to improve. Get them so excited about the cool things we can do. And it breaks my heart when I have a kid show up at the March Against Monsanto who's holding a sign saying, your science causes autism. It doesn't. And here's a kid who's going to now go through life thinking science is evil and done by evil people with evil intentions, when really we're trying to get that kid may hold the solution to the next big citrus crisis. Yeah, it's unbelievably ironic that so many anti-science websites are online. I mean, just the idea. I mean, how the fuck do you think that computer got built, son? Exactly. Right? Yeah, you're all natural. It's an Apple. This is not an all natural computer you're typing this recipe through. It's yeah. I think it's really important that people recognize that science has brought us virtually every single thing that you enjoy today. Outside of the natural world, outside of coconuts falling and you eat them, you know, there's so much that we have relied on science about, the way we stay warm, the way we keep things cool, the way, you know, we communicate with each other.
And this fear that people have about foods being modified, I think, it's a big one, and it's one of the biggest ones in this country. And so to have a guy like you come on and express why we should be concerned and why we shouldn't be concerned, and what the positive aspects are, I think it's really, really important, man. I think a lot of people need to hear what you have to say, and they need to be able to listen to it from an objective standpoint and understand that this is a very complex issue. It's very complex, and it's very important.
I appreciate that we'd have time to talk about it, because it's something that I really encourage people. There's places where you can get great resources. There's a blog called biofortified.org, which is written by scientists who are independent scientists, and it really is just an information hub about this particular topic. And some of the articles are clever. They're all written very softly. Nothing is, damn anti-GMO. It's all really about the science, and it's independent. It's not funded by any of the companies.
Have you ever thought about doing a podcast? Because you would be excellent at it.
I would love to do it. There's some funny things about that. You can't talk.
Do you have an anti-podcast clause in your university contract or something?
No, I have a podcast I do, but I don't do it as me.
Oh, you son of a bitch!
I do it as a character. And it's
no! How dare you? And you can't talk about it.
No, I can't talk about it because
what the fuck did you mention it for then? Well, they're gonna find it. They're gonna find it.
I guess the problem is that once
things from the internet.
I know, but once the cat's out of the bag, the funny part is
cat's out of the bag.
Is that that's too bad. the reason I wanted to keep it secret though, and maybe here's my appeal to don't go look for it.
Okay, but it's still secret. What's it about?
Science.
And you're a character on a science podcast?
Yeah.
Ooh.
I'm a moderator who
they're gonna know what that is.
I guess they'll figure it out.
They'll figure it out immediately.
But I'll keep it going anyway. I mean,
keep it going. Don't admit to it, no matter what.
Yeah, Colbert did it for how many years?
Yeah,
exactly.
And
so and it's very much along that line. It's very much along that line. It's a lot of fun talking about.
Do you play a dummy or a smart guy?
A dumb smart guy.
Oh, so you play a guy who doesn't understand the science, and you have to correct people, or they have to correct you? Is that what happens?
Something like that.
So you play the antagonist, and so they come along, and then they have to use you as a tool to get to the root of the problem, the ignorance that people have with science.
Essentially, yes. And then some stuff that's completely off the wall. And it's really fun because it's a great way to get the science out there, and it allows me to have some fun as a character, as a character that I couldn't have as a established professor and chairman of a department.
Totally understood.
Yeah, that also is now linked to a great song online.
What you need is a rapper name. You know how yams have their own separate name?
Yeah.
The yam, and then they have the other thing? You need a rapper name, dude.
Yeah, I do have one. Actually,
what is it? You going to write it down?
I'm not going to say it. I hope you don't.
Is it like Kaiser Soze? It's one of those things, or Candyman?
It's one better. You can even look it up online here if you want. But that's it.
I can't talk about that?
No, don't talk
about
it.
I won't violate your trust.
I think it's good because the thing is that I do want to talk to people who don't agree with technology.
Well, why don't you do this? Why don't you have a podcast where people, instead of like I've seen you spend so much time typing. I'm sure you can type, or you can talk rather quicker than you can type all that shit out.
Yeah.
So why don't you just take those questions and have people send them to you every week, and if they're not redundant, just that way you can choose. You know what you've already addressed,
sure.
And you could say, hey, we covered that in podcast 2 or 3. You would have a kick-ass podcast, man. I'd be happy to support it too.
Well, why don't we talk about that?
We'll talk about that. It's so easy to do.
Well, the one I wanted to do was the crop domestication podcast, where I talked about.
Oh, finally, someone's doing that.
Well, the one we talk about the strawberries and the yams and all that stuff. I wanted to talk about each one of their stories and how they came to be. And interview the experts. And
it's a great idea.
And so all these things are kicking around. The problem is I have 3 full-time jobs.
Whoa.
I'm an administrator. For a department of 59 faculty. I'm a full-time research scientist, and I'm a full-time science communicator. And so I literally do work 6 a.m. to midnight, 7 days a week.
Dude.
And except for exercise time, and the stuff I do there, I'm in this.
What are you hiding from? What are you running from? Running from something? No?
I don't know. I guess
seems like a lot of work.
I guess what I'm running from is I'm running from I'm waiting for one of these things to wear out where I can just cut it back to 2.
That's an amazing work ethic that you have, and I can understand why you wouldn't have enough time. But if you have enough time to do all these tweets, I'm saying even if you just did a half an hour once a week, if you just for a half an hour once a week just got a collection of, maybe you can get an intern to collect some of the best questions. I'm sure somebody'd be happy to do that. You press record on an iPhone. That's all you need to do. I mean, the quality of the recording you get from a regular iPhone is pretty much worth it. You could hold it up to your mouth and just go over the piece that people could hear you. Turn the paper. Okay, what do we got here? Okay, this one. This is important. And just ramble into the microphone, and I'm telling you, it would be popular as fuck. I'm with you. And you'd be able to quit your other jobs.
No, and that works great, actually. I have used the iPhone in my character has used the iPhone.
Oh, you son of a bitch.
and I got a nice mixer at home. I punch it through the mixer.
Oh, so you know how to do this stuff.
Oh, yeah, this is all second nature. I mean, I used to be in a band, you know.
Oh, that's right. I didn't even think of that.
But I imagine there's a couple things, and I love doing this kind of media stuff. It would be a really easy thing for me to do. It's just a question of where to wedge it into a full schedule.
You really got to try it. I think you'd be excellent at it because you're really great today. I really appreciate talking to you. Do you ever feel like moving out of Florida because it's too stupid?
You know,
let's be honest.
No, I really love Florida. I really.
How dare you?
And you know why though? But it's my job that does it. I never planned on being there.
Are you in Gainesville?
Yes.
I used to live in Gainesville.
Oh, really?
Yeah, my dad went to the University of Florida.
Oh, I didn't know that.
Yeah, my stepdad went there for architecture or something.
Well, I totally admired the faculty there. And when I had the opportunity to apply there, I applied and thinking there's no way I'll ever get the call. And I got the interview, and then I interviewed, and I thought, there's no way I'll ever get the job. And then when they called me for the job, you know, I showed up, and I've always felt like the guy on the all-star team who just gets put on the team because he's, you know, his team didn't have anybody else. I'm so surrounded by good people. I always feel very dwarfed there. But 12 years later, or 10 years later, they put me in charge of it. So I must be doing something right. But well,
you obviously have a real passion for it. And like I said, you're in Florida. You got to be the smartest guy in Florida by far. It's you and Billy Corbin. You should get together. You would dominate Florida. You know who he is? Director of Cocaine Cowboys.
I don't know him.
He's awesome.
I thought you meant the Smashing Pumpkins.
No.
The thing in Florida is every time the news story breaks about, you know, the guy having relations with a sandwich or, you know.
Florida man.
I go, oh, please don't be here. Please don't be here.
Of course it's there. Have you ever seen the Florida Man Twitter account?
No.
One of the greatest fucking things the world has ever known.
Okay, I'll watch it.
In your spare time, go to the Florida Man Twitter feed and just read. Like, it's fucking crazy how many morons there are in Florida.
Yeah, it's all true. I have a great relationship with the growers in our state and the people who are doing the farming and the people in those industries.
There's a lot of great people in Florida. Don't get me wrong.
Oh, no, I'm not.
But there's a lot of morons too.
Absolutely.
A lot of morons in California.
But that's why it would be hard to pull me away, is because you develop relationships with these people who are seriously struggling. And you look at the citrus industry, strawberry industry. With the competition they're getting is unprecedented. And these are folks down the highway who are farming to feed us good food and doing everything they can to stay afloat. And I am so glad to be able to work with them.
Kevin Folta, thank you very much. And please do a goddamn podcast. Will you, sir?
Thank you,
Please.
Joe.
People would love it. I think you could help a lot of people by answering a lot of questions like you did today. You were fantastic. I appreciate the hell out of you, man. Thank you very, very much. People, you can follow him on Twitter. It's Kevin Folta, Folta. On Twitter, your website?
Is kfolta at Blogspot. It's a blog called Illumination.
Beautiful. Is there a link to that from your Twitter feed?
Yeah, just somewhere there.
Okay. Okay. All right, ladies and gentlemen, that's it. Goodbye. Bye-bye. Big kiss.
All right. Whew.